us to learn how steel, which is a material of the 19th century but has taken over the world, whether it's bridges or towers, we see the usage of steel everywhere, from a rail line to Eiffel Tower, and that was a great session. So we are really looking forward to another enriching session with ISSDA. I would like to introduce Professor Pooja Gupta. Pooja Gupta is a professor at Lady Irwin College, University of Delhi, with 3 decades of experience in teaching, research, and training. She holds a PhD from University of Delhi and specializes in sustainable development, entrepreneurship, and design thinking. She has led collaborations with Michigan State University and the University of Michigan and initiated the annual symposium on sustainable built environment. A consultant for organizations like NIESPUD and NCERT, she has authored textbooks, developed capacity building modules, and guided doctoral research. She has also founded Urmila, an initiative empowering unprivileged women through education and skill development. So we really look forward to, ma'am, you taking over. Thank you very much. Thank you very much. As far as the speakers go, we have Mr. Rohit Kumar, Executive Director, ISSDA, Mr. Nagendra Vijayvargiya, Consultant for ISSDA. He's also the General Manager, ex-General Manager of Steel Authority of India. Mr. Rajamani Krishnamurthy, President of ISSDA, Mr. Monik Parekh, Deputy General Manager of Raajratna Metals Limited, and Dr. Deepti Gupta, Principal Architect at PNG Architects. Thank you very much. I would like to call upon the speakers, and please join us at the stage. Can I have the mic? Thank you so much for joining us, Mr. Rohit Kumar, Mr. Rajpati, and Mr. Vijayvargiya.
Thank you so much. Good morning, everyone. Heartiest congratulations to University School of Architecture and Planning, Guru Gobind Singh University, Indraprastha University, for organizing such an enriching international conference. And we are so, I would like to welcome, it's an absolute honor to be sitting here in midst of illustrious panel, and we are thankful to the organizers and to all the participants so that their takeaways are brilliant from this session. And it is indeed a pleasure that this insightful session on innovations in architectural design is being planned with the circular economy in the mind. So to me, when I come from Lady Irwin College, from Resource Management and Design Application Department, talking about innovation and design, I think it is not a choice, it's no more a choice nowadays, rather it's a necessity. And all the more when we are talking about architectural design, which contributes to 40%, built environment contributes to 40% of carbon emissions. So all the more reason that we should be very, very wise in our strategies and in the choosing the material that needs to be there, because sustainability is going to be the mantra. And nevertheless, design thinking, creativity, innovations, keeping in mind sustainability aspect is what we are looking ahead through this session in the form of architectural designs that our panelists would be discussing. And we have such illustrious panel, and without wasting time, already we are starting at 11. Without wasting much time, I would like to introduce our first speaker. Mr. Rohit Kumar is presently Executive Director at Indian Stainless Steel Development Association. He brings with him a wealth of experience in various aspects of stainless steel industry. He is a postgraduate in metallurgy from IIT Kanpur. Prior to joining ISSDA, he has been associated with Jindal Stainless Steel in their research and development department and has also gained experience in product development of long products while working with Sunflag and the steel industry, of course. So over to you, Rohitji, and please, we need to be benefited from his expertise. Looking forward.
Yeah. Good morning, everyone. Good morning, ma'am. Thank you for introducing me. I represent ISSDA. Who will take forward? I'll do it. Huh? Okay, I'll do it. No problem. I represent ISSDA, and Indian Stainless Steel Development Association is a national association for stainless steel industry. Just 2 slides on stainless steel, our association. You see there are a lot of logos there. These are our members who contribute to ISSDA for the growth of stainless steel. There are large companies, there are mid-sized companies, even MSMEs are our member, and both producers and end users are our members. So we are a very unique association where not only the producers but those who are actually using it or working with stainless steel are also our members. Some of the very quickly key areas where we work upon: market development. Yes, as in our name, development word is there. So we do a lot of market development exercise. Just quick example so that you can relate it to what we do. You look at Delhi Metro. So it came 2 decades ago. In the beginning, there was a discussion yesterday, the chief of DMRC was here, so there was a huge discussion happening whether the coaches should be made of aluminum or cotton steel or stainless steel. So there were a variety of metals where they have to select based on different criteria. Like say for metro, the criteria is, first one is it should be energy efficient, it should be robust, it should have a good impact strength. And then हम mileage की बात करते हैं, गाड़ी खरीदते हैं, so they also talk about mileages because they are running day in, day out with a lot of passengers. And then also about maintainability or say sustainability, long-term life cycle cost assessment. So everything they did, so ISSDA brings that wealth of knowledge from all over the world also, because we are associated throughout the world with different associations. So we brought that wealth of knowledge as an association. We collaborated with DMRC and discussed, and finally stainless steel was chosen for the coaches. And from there onwards, you see any city, you belong to many cities, you are students, so you see that in your city also if there is a metro, it is stainless steel. So from there we bring that expertise and development, various development activities. Educational skill development programs, we, apart from doing these, joining these conferences with you, we also do separate skill development programs. Standardization, we are there in Bureau of Indian Standard and other standard making bodies to create standards. We coordinate throughout the world, and we also offer free technical help. So if you need any information on stainless steel, we are always there, and we do not charge anything for that. Before I take you to your area of work, there are various areas where stainless steel is used. All the coaches you see, Rajdhani, Shatabdi, Vande Bharat, though it is painted at times for certain reasons, they are all stainless steel. So there is since morning, yesterday also, there are many people who keep on saying the term steel, but I'll request you to use stainless steel for a specific term, because what is corrosion resistance and what is bright and shiny is stainless steel. So these are stainless steel. Blue wagons you see is also stainless steel. The red one is cotton steel. The blue ones are stainless steel. for their, I mean, I'll not go into details. In process industry, petrochemical, desalination, fertilizer, dairy, food processing, without stainless steel, they cannot function because the requirements are so high, high temperature application, very low temperature application, very highly corrosion, desalination. You can imagine what corrosion can do. Noida is known for having bad water quality. You see taps in your home getting corroded very quickly. So you can relate that in a desalination environment, how good materials are required and long-lasting materials are required. So similarly, there are many other applications. So I'll quickly move forward. So just for your, since there are many students, just for your basic understanding what stainless steel is different from steel, is that when you put certain amount of chromium into iron, then something happens metallurgically and it becomes stainless steel. So what happens when there is enough amount of oxygen is available in air, so chromium is there in the metals, it combines with oxygen and makes a chromium oxide layer. Now you say, okay, it is a layer, if I remove it, scratch it, and if I do some operation on it. So imagine utensils in your home, which is the best example for stainless steel. So you will see that even if you scratch it, it doesn't start corroding. So this self-repairing lever, oxygen is everywhere, it keeps on self-repairing. So chromium is responsible for making it corrosion resistance compared to steel, which corrodes easily due to ferrous oxide formation and all. So something is required, 10.5% minimum chromium is required so that metallurgical magic starts happening. And beyond that, you can keep on adding things into it. So if you go and add nickel, if you go and add molybdenum, if you go add nitrogen, then different grades of stainless steel comes into picture with different varieties of strength, corrosion, and many other properties. I'll go into that a little bit. So these are different grades of stainless steel. So let us not talk in detail about grades. Let us talk about my topic, which is in coastal region, when disaster happens, why material is important and sustainable material is important. So India has a very large coastline. You know, many of you must have lived in coastal cities, and you will see a lot of things happening in coastal cities. So what is a disaster? It can come in terms of high wind, which is a cyclone is an ideal representation. It can come in terms of fire. Unexpected fires can happen. Impact loads and earthquakes, both are similar things, but imagine earthquake happening and then there is some other impact load like two trains crashing to each other is also an example impact load. Then flooding water and such areas, and of course pollution also now is a natural disaster. I will consider it as a natural disaster because the way we are polluting our cities, Delhi is one of the highest polluting cities in the world. So what was happening in the coastal area has also started happening in Delhi in terms of corrosion because our environment is so toxic now in terms of many other, carbon dioxide is one thing, but you have also many dangerous elements in air also now. So going forward, I'll 5 slides, script slides for why stainless steel, those properties of stainless steel which will be used in disaster prone areas. First, it has very high strength. So you have different grades of stainless steel giving you different strength levels. If you compare it with steel, carbon steel, which is normal steel, then obviously many a time the strength to weight ratio is sometimes 1.5 to 2 times. And there is a phenomena called work hardening, which even if you work hard on it, it will further improve the strength, but let us skip this slide. This is much easier to understand. So when I say strength to weight ratio, it means if you are creating some kind of platform, it's a simple design which basic to understand. So simply supported platform, you have certain thickness you have selected. Now if you want more space inside that platform, obviously you have to thinner the section. So how you can make the section thin? Because you need some high strength material so that you have the same load happening on that platform, but you still need more space, so you select stainless steel in that way. Similarly for elongated, if you keep the thickness same, but you want more elongation in your platform so that you have more access to that area available, then you will obviously choose high strength to weight material. So these are examples how to make advantage of stainless steel. Then there is work hardening, which I was saying. If there is a plain sheet and if you make it is in a trapezoid, you see all the roofs, you see curves on the roof. Why it is done? It is done to improve the strength of that sheet, because if you put a plain sheet, you will not have that strength. So that work hardening is prime feature of stainless steel, and it is used in making such high impact areas. Like this, yesterday somebody was showing it. So in terms of impact, earlier those coaches used to get crumpled because it was cotton steel, normal steel, which used to have lower strength. So a lot of deaths and accidents and such unfortunate features used happening. Then railways completely switched over to stainless steel. LHB started first, and then all the coaches now, 2018 onwards, everything is stainless steel. So you see those accidents happen, rollovers happen, impacts happen, but still those crumpling is not happening because of the good impact resistance. Third, fire resistance of stainless steel. Very simple curve you can see. There are two lines, dotted and solid. This side is stiffness retention factor, meaning in loose terms you can say how much it has the ability to withstand the load. Then if you see at 700 degrees centigrade, starts from 400 degrees centigrade, carbon steel is losing half of its strength, and going forward 800 degrees centigrade, it has almost lost all the strength. While stainless steel, certain grades of stainless, I'm not saying all grades of stainless steel, but certain grades of stainless steel, even at 800, 700 degrees centigrade, it is still half of the strength is still there. Now imagine the right side, if a building catches fire made on a structural steel, you remember that World Trade Center collapse. So if you have such high heat application, and the two things will happen. First, the building has to withstand the load for a longer period of time so that you do most of the evacuation. Because if a building suppose falls due to certain heat application in say 2 hours, and if stainless steel prolongs it to say 8 hours, then obviously you have more time to do evacuation. Other thing, if the fire is not very high in degree of temperature, then you can reuse the building because still that damage has not been done. So very good in fire. Some test has been done to prove, but I'll skip those. It can be reused. Like this post office was this cladding of stainless steel. 50 years down the line, they wanted to change because it was boring to see the same thing again and again. So they removed all the panels, redo some modification, added certain things, and created a whole new thing with the same material by having minimum addition. It is very clean for the reason in most of the handrails and other applications you see stainless steel because it is easy to clean. All the bus stands in Delhi is stainless steel, easy to clean. We have habit of spitting and putting posters and everything. So it is very near to vandalism proof or whatever terminology you want to use. Even in your bones you see either titanium or stainless steel material going inside. Very quickly, now I think I have 7 minutes more. So say disaster. This is a very common feature when I talk about disaster. This was Andheri footover bridge and other station collapse. You remember in Mumbai, a lot of media attention was there, and so many people died. So after this, and this happened because the environment, corrosion, maintenance was an issue. There was some load variations also, and outcome, what was the outcome. Similarly, in many of the coastal areas, this is a common feature. Mumbai I am taking as an example so that it flows with my presentation. If you go to Odisha or Vizag or any such coastal areas, this is very common. Now in Delhi also, you see this is a Mumbai, but every year during rainy season, Ajmeri gate side, you will have that picture of that bus. People saying, "Oh, har saal wahi picture repeat hota rehta hai." So it's a issue in Delhi also. It's not just that it is a Mumbai issue. So water is there, and water obviously drying, wetting. It's a situation where material degrades very quickly. This station was collapsed through 2 days for station to maintain things, and there is a operational loss. So not only the loss of the replacing the material, but also the loss of remaining it operated and difficulties faced is a huge loss. It's a big issue. Now, obviously, the reason is most of the time it is corrosion, and corrosion can happen in such a severe way because you see what the collapse to the other side was there, and still people are standing there. This bridge is not even fit for rehabilitation, so it has to be completely dismantled and new material has to be brought in. So what happened after that? Several bridges were made in stainless steel, like this Himalaya bridge. It was made in stainless steel. You look at it, the look itself tells you the story. And that was in certain very economical grade of stainless steel. Then there was this Mrinal type bridge where, it was over a Nala. And Nala is something where toxic fumes are coming. So every 10 years, those steel structures used to corrode like anything. So they used a better grade of stainless steel, which is called duplex stainless steel, very high strength, very high corrosion resistance and made this bridge in that place. Another disaster, I would like to take this example. You remember many cyclones coming and having very typical names, like this Vizag, Hudhud was the name for that cyclone. And this airport of Vizag, the whole roof collapsed in the sense in pieces and fall onto the ground. You can see the picture, you remember that. Now imagine those roofs were not polycarbonated sheets or sometimes, the steel painted steel ones. All over world, most of the new airports are having stainless steel roofs, and these are not very shiny. If stainless steel comes to your mind, don't always imagine that it is a shiny surface. It comes in various surfaces, various finishes, even matte finishes, even finishes with certain kinds of coatings on stainless steel. So initial loss to the airport was in the range of somewhere 75 to 80 crores. Source is the Hindu newspaper. Imagine 80 crore of loss coming to this airport if they would have embedded those 10% of that 8 crores of rupees in the roof. It would have been in stainless steel, and they could have saved at least 60 to 70 crores of rupees. So Fani, Odisha, it was a very typical storm which destroyed quite a lot of part of Bhubaneswar, where the estimated loss was 12,000 crores. Now the airport again totally collapsed, the roofs, everything is standing, that mural, the big tree is standing, but everything else destroyed, and the water coming also destroyed most of the terminals, computers and everything. So again the loss was so huge that even 10% of that cost could have taken stainless steel, because generally the moment I say stainless steel, many of the learned people will say, high initial cost, why I should consider your material. But imagine these situations, especially in disaster prone areas where stainless steel is the only solution. Similarly, petrol pump roofs were teared off. These are signage boards which fall onto objects, trees, and even certain deaths happened. Similarly, in the same Odisha airport, railway platform roofs were teared off, almost finished, and the whole city looked like that. You see the left picture, it's not my picture, it's a published picture I have taken. But one thing happened there, and this was also in the news. I'm happy to share it with you. The title was, Why Cyclone Fani Couldn't Do Any Harm to Bus Shelters. You know, they established 100, very recently, just before storm, 2 years before storm, 100 new bus shelters made in stainless steel. So every roof, everything was in distorted situation, but only these bus stands were standing spit and clean and everything. So this was an ideal case for us to project our material as a totally sustainable material. And you know, the moment we talk about circularity means everything has to be, there is a timeline for circularity, and stainless steel fits in that timeline. Same properties were utilized. Now the roofs has been there in railway stations. This was made 15 years back by Steel Authority of India, supplies the material, and it was in Mumbai. But unfortunately, so far we have not been able to convince the policy makers that initial cost is not just important, so that you go for the lowest cost material. Please select, and I went there myself to check what maintenance they are doing after 15 years, and believe me, their maintenance book has no column for roofing. Because they never thought about it, यहाँ से पानी लीक कर रहा, वहाँ से एक रोड हो गया, ये हिल रहा है, या कुछ आवाज़ आ रही है हवा से हिलने से. So it was very funny that I did not find a maintenance logbook there for this particular roof, and this should be the enough example or enough opportunity for policy makers to understand the life cycle costing. Roofs, generally we think that if it is a stainless steel roof, it will heat more and it will create more heat islands below the roofing. No, it is not like that. If you look at the solar reflective index, which you all have studied in 10th and 12th class. So solar reflective index for certain stainless steel finished grades, surfaces are better compared to other materials. And these are some of the examples of the roof. Now fire, very few slides, just 5 minutes more. When you do, Yeah, sure. So there are claddings everywhere which catches fire. Stainless steel is the ideal in that sense. In tunnels also, because we are building a lot of tunnels, if fire happens, it is very dangerous. Due to disaster, there can be fire from other sources also. So tunnels also, claddings and many other applications are in stainless steel. The under dustbins which usually flows in a high wind environment, now underground dustbins has started becoming popular. It remains underground, it comes up, take the material, then put it under again under. Then these are not some European examples, these are examples from our own cities. Poles, smart poles in Delhi, everywhere you will see stainless steel poles for the reason that is sturdy and all those things. Thank you very much. So I hope I have finished it in time. If you have any question answer, I think it will be taken in the end. Thank you very much.
Thank you so much, Mr. Kumar, for enlightening us for, how the material suitability is important in different weather conditions, different types of disasters, and etc. And stainless steel comes handy. So thank you so much for making this point very, very clear to all the audience that one, if you want sustainability, you need to focus on circular economy, and also the material suitability has to be the mantra. Thank you so much. So it's very kind of our speakers to suggest that let's have the session ongoing and forego the tea. So I'm sure the organizers will look into. Our next speaker is Mr. Nagendra Kumar Vijayvargya, consultant ISSDA. Mr. Kumar has worked in prestigious organizations like SAIL and holds experience in many profiles. His core area of work has been quality control, marketing, and sales of stainless steel flat products during entire term of his work with SAIL. He is B from Malviya National Institute of Technology, Jaipur, PGDM from IMA. Now Mr. Vijayvargya is superannuated and working with ISSDA as a consultant. So over to you. Thank you.
Sorry to interrupt. I would like to invite Mr. Monik Parekh, Deputy General Manager of Raajratna Metals, to come and join us on the stage.
We can have a big round of applause.
Thank you very much, sir.
Good morning, everybody. Before I start my presentation, may I ask the students especially, what do the Jagannath Temple, Puri, the Statue of Liberty, and the City of Venice have common in them, apart from their status as world landmarks? Okay, we'll go ahead. Have you ever wondered how we can preserve buildings that have stood the test of time? And how can a material that is invisible to the eyes be the reason why our heritage structure continue to stand? And we'll further see what if I told you that the solution to saving ancient monuments could be hiding in plain sight, means we can't see that. So today we will be discussing the crucial role that stainless steel plays in the restoration of protection of heritage building. These structures are national and global treasures that help preserve our cultural identity. However, they are constantly at risk of deterioration due to environmental factors and human activities. Restoration aims to safeguard them for future generation with minimal maintenance, and stainless steel has proven to be the indispensable material in this. It is invisible yet invaluable. Stainless steel provides long-lasting protection against corrosion, environmental damage, and structural instability. So let us see some case studies. Okay, before case studies, the United Nations Educational Science, that is UNESCO, has provided this booklet, gives guidelines where stainless steel plates, screws, rods, etc. shall be used. Similarly, our own CPWD has brought out a handbook of conservation of heritage buildings, and INTEC, that is also has brought out this booklet, Indian National Trust of Art and Cultural Heritage. It is prepared in January 2016. It is also given the various schedules of rebars, studs, tubes in stainless steel. Now let us see the case studies. We'll see the Jagannath temple. We'll see what are the common things in these monuments. This was built in first quarter of 12th century. It is hardly 2 kilometers away from the sea. It is 66 meters high, and no mortar was used. Stones were joined with the help of wrought iron U-shaped clamps or dowels. So the maximum damage has happened because of the rusting of these clamps. I had visited this temple some 40 years back and had seen some damages, but I happened to see again this in last January. You can see some picture where the work was going on. So you can see that corbel replacement was done, stainless steel was used, structural reinforcement was done, where again stainless steel truss was used, and wall were confined using stainless steel flats, and the shikhar, the top, also was preserved with stainless steel using epoxy mortar and stainless steel. Now we'll go to another example. This Mani Mandir complex at Gujarat got damaged in the last earthquake. It was Bhuj earthquake in 2001, and lot of damage had happened. There were cracks in the wall, shifting of the stones. I don't have a pointer, but if you see in the top left-hand side, the perpendicular walls were connected with stainless steel rods so that there is no shift there. Then on the middle you can see also there is a horizontal stainless steel reinforcement bars are there, bands are there, and on the right side reinforcement was increased 600 mm spacing along the height of the wall. Again the arcs in the same Mani Mandir, you can see on the left side turned buckle were used so that it doesn't shift, and on the right side you can see the middle keystone was stabilized using stainless steel rods. Again, another on the right side you can see in the dark lines they are all stainless steel. On the left side also you can see on the darker lines they are all stainless steel. Another example is Ujjayant Palace in Agartala. This was it was built in 1901, and now it is an assembly house of Tripura. See that they have used various material, GFRP, aluminum, carbon steel, but stainless steel angles were used. You can see in the photograph, 8 mm thickness and 200 mm width. Corners were reinforced by this. anchors, this stainless steel was, bolts were used as anchors. Now it is a example in Paris. It is practically not a rehabilitation, but they combined two buildings and showed that it is a single building. They used laser cut sheets of 12 mm thick, and different designs they used for in perforation, and around 60% perforation was done, so that air, etc., there is no problem, air and light. Now comes to Statue of Liberty. Everybody knows that it was installed in New York in 1886. Galvanic corrosion took place, and they started rehabilitation in 1986. Designer had thought that they use the galvanic corrosion, they had thought that time also, but the envelope design and subsequent modification, because of subsequent modification, it got damaged. So they used 316 grade stainless steel for armature. Then secondary framework of duplex stainless steel was used, which is a higher grade and tougher and higher corrosion resistance. And 316 grade stainless steel was used to replace the staircase. Now it is an example of in Morocco. See, this mosque was made in 1993, and they used around 585 euros. But as quickly as in 2005, they found that it is got damaged, so restoration was required. They used structural slabs and pillars. They removed all the damaged portion and replaced it with stainless steel rebars of duplex stainless steel, and 1,300 tons of these rebars were used, and they spent another 50 million euros. So if they had used stainless steel at the first stage itself, this 50 million they could have saved. Now Venice city is battling against the nature. You know that Venice city is, you can see it is in the sea, because the sea water is there all around. They have a lot of problems like rising water level, sinking grounds, high tides, salt water exposure, erosion from motorboat wrecks. So last 10 to 15 years, they are already working on this. On the top, you can see that stainless steel pipes have been used. And the bottom picture, you can see that stainless steel wire rods, stainless steel pins have been used. So brackets and pins, handrails, gas and water pipes, water bus terminals, reinforcement of cast iron bridges, all they are using now stainless steel. This particular bridge was a wooden bridge, but they have made of stainless steel, duplex stainless steel grade 2205, but they have clad with wood so that it looks like old structure. So I conclude here that heritage buildings and monument cities are national world assets. They help us to understand our past and learn from it, but we have to restore it, and we should not, we can do the maintenance, but we should not remove the old glory. So we have to be very careful with intrinsic properties like corrosion resistance, higher strength and formability. Stainless steel plays integral role in the restoration and preservation of our heritage building. Thank you.
Thank you so much. infrastructure, I would say, age and suitability. Thank you so much. Now we have the third speaker, Mr. Rajamani Krishnamurthy. Mr. Rajamani has over 3 decades of industry experience, out of which over 2 decades in the key managerial levels in SL Group, SR Group, RPG Group, JSW Group, Confederation of Indian Industry, and large MNCs. He has a proven track record of delivering result-oriented, value-added services in a dynamic and competitive environment on time, every time. He is a seasoned professional with great acumen in policy advocacy, regulatory affairs, crisis management, brand building, and media management. He has excellent, impeccable relationship with corporate houses and with governments, both at working and decision-making levels. He helped align business environment as per the guidelines stipulated by the government. So we look forward to hearing from you.
Thank you for giving me this opportunity. Good morning, students, professors, my colleagues, respected moderator, and ladies and gentlemen. This is a topic, which yesterday Mr. Purohit briefed beautifully, that what his grandmother used to do, making godaris. Not only godaris, we have seen in our childhood days that even food which is left over, as compared to the stainless steel, so the leading to high material cost and environmental stress. So now the question is, how do we build an infrastructure that lasts? And the answer lies in stainless steel. And we welcome all the sustainable, materials which support sustainability and progress. SS is one of them which fits perfectly into all these buzzwords, which is sustainability, circular economy, and life cycle cost, less life cycle cost. All these parameters, SS fits in perfectly. So let's explore why its futures of sustainable construction is required. Now, understanding life cycle cost, what we normally do in India is, which is very unfortunate, we just take up the initial cost and the installation cost, which comes under any particular project. But we don't look into what will be the maintenance cost, what will be the replacement cost, what will be the energy cost, what will be the operational cost. So LCC means, which comprises of all these, and the life cycle cost, which over a period of say 50 years or 60 years, how much does it save on a total overall project cost. So that going to matter in any infrastructure projects. So imagine a situation when we want a house to be built and which needs to be lasted for at least 50 years. Then imagine a public infrastructure which will be used by so many peoples, in India. So that needs to last at least for 100 plus years, if not more. So this is a classical example. I thank Rohit for making this slide for me. It gives you a complete what we overlook, the green portion which we overlook at the time of installation. So the installation, it has been very, perfectly put. If you look at the stainless steel vis-a-vis the normal project cost, the installation cost and material cost is much lesser. But if you look at stainless steel usage, that cost is slightly higher, which is, understandable. But we overlook all the above cost, that leads to a huge, the picture is giving, a car which is of 1936 made of stainless steel. Looks even new today, whereas a car which is manufactured much later, look at the condition of that particular car. So that's why life cycle cost is mandatory while doing public infrastructure, especially at the time of DPR stage. Now, the advantage of sustainability. So it ticks all the right boxes, corrosion resistance, longevity, 100% recyclability, minimal maintenance, and it is, as Rohit mentioned in his presentation, it is fire and seismic resistance it has within it. So stainless steel is the preferred material in all these parameters. Now the case studies, which yesterday DMRC also mentioned it. Delhi Metro, as Rohit also mentioned in his presentation, that Delhi Metro wanted to have a combination of various other materials. They were looking at aluminum, they were looking at cotton steel, they were looking at stainless steel. Finally, they chose stainless steel because it was the fit material for the purpose for which it was, they initiated that particular system in place. So over 60% of lower maintenance and repainting cost and lighter structure and lower energy consumption mattered in choosing stainless steel for their coaches and railway station development, which gives you naturally an aesthetic sense when you look at it. All the stations, metro stations, if you go and look at it, I promise you that you'll be comparing it with any leading countries in the world. You find that, we have also matched that particular quality, or in fact, better than them. The second, the second one, which I forgot to incorporate this, is the Champlain Bridge, Canada, which was again, extreme weather corrosion made the conventional steel impractical. So they shifted to stainless steel, used duplex stainless steel, giving 120 plus years lifespan for that particular bridge, saving minimum 25 million dollars, in fact, in repainting that particular bridge. So this is a great saving. And the last one is Singapore New Water treatment. Earlier it was, galvanized pipes, and which was demanding. Singapore is one country where they used to treat wastewater and, and make it potable and for drinking purpose, because the natural resources in Singapore are very, very minimal. On that particular pretext, what they thought of is, using stainless steel for their water pipelines and also the storage tanks. So 50 years lifespan with zero rust related to no contamination, and the water was pure and easy to drink. So the example proved one thing, that stainless steel is not just an option, but it is an investment in resilience and longevity. Now this is a picture which, I would like to share with you. The two prominent structures, one is the Eiffel Tower, and which was constructed in made operational, it was constructed in 1886, made operational on 1889, which is 135 years old. The annual maintenance cost, even today, is above 4 million euros because of painting and other this thing. Leave aside the major repairing works since 1889. On the other side, if you look at, it's a Chrysler building in New York, which was, the material used there was stainless steel. The initial, the operational since 1930 at almost 95 years old. Annual maintenance cost is just $831. This is the bridge which I showed yesterday also. The one on the forefront is made of stainless steel, which was made 70 years ago, and which is still looking fine to go for another 30 plus years, in fact more also, without any maintenance. On the background, if you see the ruins which are visible, they are made of carbon steel. And look at the condition, it was just made 30 years ago, and it's only the remains are there. You know, you can't use that particular thing. So one which was considered 70 years ago is still ready to go for another 50 years. And some of the developments which Rohit already showed in, footover bridge in Andhra Pradesh, which was the first stainless steel footover bridge, and the railway station development. These are the major projects in railways and PWDs which is happening currently in India. This is the airport, Chennai airport, in which Charanjit Shahji was showcasing yesterday. So all this, the golden color, they are all made of stainless steel, so you get multiple shades, color shades also available in stainless steel. And tunnel construction, you know, all the cable trays earlier used to be on galvanized sheets. So which they have replaced it to stainless steel sheets because of, you know, on a tunnel, the moisture is a common factor which causes the corrosion. So just to avoid that, to a major disaster in tunnel when a vehicle is going due to electric short circuiting and all, so they use cable trays, which look aesthetically very good. On the, you know, Northern Railway, you can see the USBRL tunnel project. So the road ahead, what we wanted to do is a policy and government push for life cycle cost in tenders at the DPR stage itself, and incentives to be introduced for recycling materials. For any recycling materials, you know, sustainable materials, not only stainless steel, whichever qualifies for that particular parameter should be incentivized. Industry academia, events like this should be made, because you are the future architects for building, nation building. So you must use these, initiatives to take care of the construction for the future generations. And public awareness, that is train engineers, existing engineers, policymakers, stakeholders, and see stainless steel as an investment and not an expense. And in conclusion, let me leave you with a simple thought. What we build today is not just for us, but for generations to come. Sustainability is not just about reducing our carbon footprint today. It is about ensuring that future generation inherit infrastructure that lasts. The real cost is not what we pay upfront, but what we save over the period of time of the project. And stainless steel is not an expense, it is an investment in India's sustainable future. Let's shift our mindset from cheap to a long-term value and build for generations, not just for today, for the future who are going to enjoy this. Thank you.
Thank you so much, sir, for making so very clear to the participants that sustainability has to be seen with a different perspective. And the perspective is take care of longevity, take care of resilience of the built environment. And thank you so much for guiding us that we need to, instead of just seeing the initial cost, we need to see the other costs that the buildings will have and how stainless steel is coming handy and changing our mindset, and also appreciative of how sustainability was very much the mantra earlier and how it is now. Only thing is, let's look after changing the perspective and still be sustainable in our choices. Thank you so much. We have We have another illustrious speaker with us, Mr. Monik Parekh. He's working with Raajratna Metals India Limited since 28 years, currently working as Deputy General Manager, Sales and Business Development. In journey with Raajratna, he has helped to develop wires for many various applications in stainless steel and nickel alloy, like spring wires, medical and filtration profile bars, stainless steel reinforcement bars, and various others. It would be so interesting to listen to you, sir. Over to you.
Hello. Yeah. Good morning, respected dais members, professors, students, and all other respected guests. It's really wonderful to see to give presentation with this fraternity, and thank you, ISSDA, for giving us this opportunity. Before starting, I would like to show what Raajratna can offer in stainless steel and what we are manufacture and what controls parameter we are keeping to manufacture various kind of stainless steel products. Please check the video.
Ask anyone how the future will look like, and they will talk about flying cars and personal robot assistants. But if you ask us, we will tell you. World, proudly imbibing the spirit of Make in India. We are an ISO 9001-2015 and ISO 14001-2015 certified organization that has won numerous awards and accolades. We are a truly environment-friendly organization that runs on green energy generated from windmills. The company started in 1990 with a planned production capacity of 600 metric tons of stainless steel wires annually. As time and tide kept changing, we kept upgrading to newer products and better techniques in our plants located in India and Indonesia. The process begins with procuring the best quality raw materials. Through a series of tests done at our own plants, we ensure that our raw material is uncompromised in quality. After a thorough inspection of raw material and a series of tests, it is approved to pass to the respective plant for specific product manufacturing. Over 900 skilled workers and 200 plus staff make sure the highest quality standards are maintained at every step of the manufacturing process, and deadlines are met without any glitch. We manufacture wires for various applications. Bright bars and solid sections in hex and square, profile wires, medical wires, reinforcement bars, and many more. Apart from that, we also produce 100% defect-free wires by the process of shaving for critical applications. We at Raajratna also refurbish our own dies to maintain the die profile, as it is the heart of the wire drawing process. High-quality stainless steel and nickel alloy spring wires are a superlative offering. These are available in soap-coated, nickel-coated, and bright finishes. We produce a range of welding wires, including MIG wires, TIG wires, core wires, and SAW wires, which are available in customized packing options like bale packing. For cold heading applications, we manufacture soap-coated, copper-plated and copper moly-coated wires free from surface imperfections. We specialize in manufacturing electro-polish quality wires with excellent surface finish. We also manufacture spoke wires which find application in bicycles, motorcycles and luxury cars. We have set up a dedicated plant for manufacturing fine and superfine stainless steel and nickel alloy wires. We manufacture profile wires in over 200 different shapes on universal cold rolling mills to meet critical industry applications. For guaranteeing the close dimensional tolerance, we have set up our own roll grinding facility. We also produce medical wires and bars as per medical industry standards. Our bright bars come in the range of 3 mm to 50 mm in 3 different finishes: polished, ground and chamfered. Our wires in cut length range from 0.2 mm to 3 mm. We also produce solid sections in hex and square. We are the only company in India that produces reinforcement bars in stainless steel as per BS 6744 standards with CARE certification. We also manufacture reinforcement fibers with CE certification in straight, crimped and hooked ends. We offer customized packaging as per the customer's requirement. Before the product is shipped, it goes through various tests at our fully equipped quality assurance lab. Our products find application in various industries. A well-laid logistics facility ensures that our clients never face any delay in delivery or product damages. To ensure on-time delivery to our international clients, we have 2 subsidiary companies. Inox in Europe, with warehouses located in Italy, United Kingdom, Spain and Germany. And Raajratna USA in North America, with local warehouses in Chicago, Connecticut, Houston, Los Angeles and Mexico.
We are continuously evolving in technology and automation. When we see the progress of our company, we also see the progress of our country.
Continuous training and best safety practices are a regular regime at Raajratna. We also offer lodging facilities to our workers to ensure efficiency. Our products are further taken beyond by our subsidiary companies.
Thank you all for seeing our video. As you have seen, the various application of stainless steel wires, profile wires, reinforcement bars, stainless steel wire ropes, mesh and tubes. We are one of the finest manufacturers of stainless steel and nickel, and if you see the sustainability of stainless steel, it's more than 100 years. It has been said that previously we used to use the sag wood our ancestors were using. In replacement of that, now we can use the stainless steel products. And if you sell that stainless steel products after 100 years, you will get more cost than your current purchase cost. I would like to give you a brief presentation. As you have seen, that we have a manufacturing facility in Ahmedabad, Indonesia, and we have offices in Mumbai, Delhi, and across the world. We are offering stainless steel wires for automotive products, oil and gas, paper and pulp, medical equipments, power plants, shipbuilding, aviation, textile, and architecture. Basically, stainless steel is having four kind of grades. It's austenitic, ferritic, duplex, and martinistic. The major use in architecture is austenitic and duplex. Austenitic majorly 304 and 316, which consist around 17 to 18% chromium and 8 to 11% nickel. Chromium, which gives the good corrosion resistance against the chloride atmosphere. And duplex, where you can use where the high chloride atmosphere is there, like where marine projects and other coastal areas. In duplex, there are the grade called 1.4462, has a generally better corrosion resistance than the standard austenitic stainless steel due to higher content of chromium and presence of molybdenum and nitrogen. Maybe in overall project is 4 to 5 times higher than the traditional material, but over the period, if you say the life cycle cost is pretty less because stainless steel doesn't require much maintenance. There are the various examples like the Chrysler building, Mr. Rajamani sir has said, which was built in 1930, and till now it is inspected only 4 to 5 times. It doesn't require much maintenance. This is the project ISKCON Mayapur, which is Asia's largest ISKCON temple. And if you see the dome, blue color dome, we have supplied a 304 grade rebar, approximately 1500 tons. This is one of the iconic project of India, and in the very first they used this 304 grade. In many other projects, they are using a 410, but Raajratna is offering austenitic grades in rebars. And Raajratna is the only company in India who is having the CAS certification of UK. Apart from that, we have completed many projects in US of Swaminarayan Temple. Even in India also, we have completed the Swaminarayan Temple in Mohali. Also, we have supplied many rebars, reinforcement bars, in Middle East for highway constructions. And currently we are exploring the opportunity in Canada and Mexico. They are widely using stainless steel rebars for highways and buildings. This is already we have discussed many times. So if you see the use of stainless steel, there are this memorial, if you see, Utøya, Norway, where the thick strips are used for architecture and aesthetic look. This is a Venus Rising, again with the pipes, bars, and many other profiles are used. This is the seasonal flower. It's a Tokyo, Japan. Consists of colored mesh. Now, colored mesh is a very good idea. We are also exploring the possibility to further develop in India. Currently, no one in India is manufacturing this. The tiger enclosure, this is again of a mesh wire ropes of wire ropes. Our sister concern company, Raj Tubes, has done many projects for airports, zoo, and recently they are working on the Vantara project. And they are supplying tubes and wires for that. Now the woven stainless steel fabric is again used in the ceiling of this project in Paris. We can offer the stainless steel wire mesh, wire ropes, profile wire. Some of the pictures, it's already displayed. So you can see and how.
Getting to know the innovations that this company is doing in the form of, SS wires and other foams where everywhere they can be used. And thank you so much for showing the case studies where actually Raajratna Metal Limited has used these wires. So, and also the consideration, a very important point that he has made is not only the LCC cost, but the overall resale value of stainless steel would be higher than the current value. Am I right? Yeah. So thank you so much for doing so. Thank you. Yeah, please.
I would like to now invite Dr. Deepti Gupta, Principal Architect at PNG Architects, and share her insightful views. Dr. Deepti Gupta.
So the last speaker for this session is Dr. Deepti Gupta. As already stated, she is partner at PNG Design Consulting and architectural and project management consultancy handling multi-dimensional projects of various scales. An architect and project manager with both the degrees from School of Planning and Architecture, New Delhi, she has professional works in architecture, project management, and tensile structures to her credit. She is also a tensile consultant with a Master's of Engineering in Tensile Membrane Structures from Germany. She has 34 years of work experience in the same. Due to her passion for academics, she has taught for more than 2 decades at School of Planning and Architecture, New Delhi, as a visiting professor, along with her practice. Over to you, Dr. Gupta.
Yeah, hello everybody. Oops, can you just adjust this? Yeah, I think the sound is quite clear, right? Hello? Am I speaking too softly? This is fine, okay. Okay, so today here I'm, since my area of expertise has been tensile structures for the last 3.5 decades, I had the good fortune of studying about tensile structures in Germany, about 35 years ago from the very creator of tensile structures, Fry Otto. So today I'm going to discuss the tensile structures and application of stainless steel. So tensile structures, we think they are very hi-fi, but actually traditionally all the tents that used to exist, they also come under tensile structures. So these are thousands of years old, hundreds of years old, and so on. Circus tents were a little larger. They used more of the technology that we do. Then in the 20th century, more high-tech tents started coming up, and a new era opened up. So this is Fry Otto in his atelier. So these are some examples of some modern structures. The one on the top left is the Sony Center in Berlin. And then the second one is the Montreal Expo of 1967. The one after that is the Institute of Lightweight in Stuttgart, the London Dome, then something in China, and so on. So what are tensile structures? Tensile structures are basically structures which use tension as their basic load-carrying force. So mostly if you make a building, your columns and all, they are subjected to compression, which means it's a force which is coming down like this. But tension would be a force which is pulling it like that. So if I were to give an example, if you were to take a normal pencil or something, and you tried squishing it or buckling it, it would break quite easily. But if you tried pulling it apart, it wouldn't break easily because a lot of materials, they are stronger in tension rather than in compression. So when we make tensile structures to make a membrane roof, because now we are dealing with flexible members, so the members have to be tight. They have to be pre-tensioned or pre-stressed, and we cannot have a normal flat roof. We will use a curved roof. So the curvature can be either anticlastic, which is one axis and the other axis, or they can be synclastic, means both the axis, the curvature is in the same direction. But whereas these surfaces, if you pull them tight, they will be stable by themselves. For this kind of a structure, imagine a ball or something, you would have to fill it with air for it to be stable. So how to generate an anticlastic surface? If you just imagine that in one axis, you have loads, and in the other axis, you have, let's say, gas balloons, which are pulling it up. You would get this. A very good example of an anticlastic surface would be a horse saddle. So the design process for tensile structures is not the same as our regular structures, because form finding is a very important thing. You cannot have a normal, like rectangular forms and stuff, and the form of the roof cannot be arbitrary. It has to be made in a way that it is stable under the forces that we are generating. So, even though like every design, this is also a back and forth process, but mainly we can say that it is evolving a suitable form, then you decide a workable pre-stressing method, you test the proposed structure for stability under the loading conditions, and then you do the dimensioning of the parts, the fabric, the steel, etc., etc., and then you have a choice of material. So these are basically form-active structural systems because the form of the structure itself will play a role in the transfer of forces and in the stability of the structure. So earlier they used to do physical modeling of this. So physical modeling can be done either with a fabric or a soap film or hanging chains, which will give us the form appropriate for that flexible material, and yet it should be stable. Some of the largest structures till about 30, 40, 50 years ago were done using these methods. But now we have computational models, means computer softwares, so just like any other engineering. The biggest difference in the regular structures and the tensile structures would be that this is, normally we use linear analysis for the structural computation, and this is a non-linear analysis, which means that if this is something and you load it, it's not going to stay the same. It will deflect a little bit. So all the subsequent forces will change. So it's an iterative process. It doesn't go like this, it goes like this. So they're very different computations and calculations for nonlinear processing. So the form finding can be done using software. This is one example in which we have defined the boundaries, the high points and the low points, and then it will generate a surface. So that makes it quite easy for us. This is another example of the form finding process. This is another software, that is 410. This is PAM-LISA. In the first two images, what you can see, the colors and all, this is after we've applied the loading. We've seen what are the stresses generated. So then accordingly, we can choose the strength of the material, etc. to be used, and the sections. Then the fabric, to generate that form, you can't just pull a fabric stretch like that. Just like you tailor any of our clothing, you have to tailor that shape also. It's not a rocket science, just like tailors do it, this can also be done. Of course, we have softwares to help with it, so that makes it even simpler. But even when they weren't softwares, I remember when we were like very young, we used to take a fabric model, stick pieces of paper on it, and then cut it, and then derive a shape. Again, some drawings of, these are real structures. So what you need to, this is a fabrication. So this is a factory in which rolls of fabric, the fabric that you get, it comes in rolls. In the same way, like, you go to a cloth shop, you get rolls of fabric that you can buy and you can get your clothing done. So the only difference is these rolls are bigger and this fabric is stronger. It's a structural fabric which has certain structural capabilities and specifications. So this is the installation. As you can see, first you install the steel structure and then you put the fabric on it. So this is an example. Okay, so tensile structures can be based into few broad categories. One is a membrane structure, cable net structures, pneumatic and retractable. So fabric roofs, these are the commonest. In this, the fabric itself is a structural membrane. But it does not mean that it will not require steel. It will still require a lot of steel, we'll just come to it. So some examples of this. Okay, so a cable net roof, the structural net carries all the loads and the forces, and the roofing material itself is only there for weather protection. For example, in this Munich Olympic Stadium of 1972, the cable net is there, and then there are these acrylic shingles on it. Oh, some pictures of this. This is actually one of my really favorite place. You have to go there once in your life. Just the scale and the sheer design of it will like blow you. Then pneumatic roofs. Pneumatic roofs are a little less useful because you have to constantly keep it under positive pressure. But here we see, like for example, this, the top one, the Roman Arena Nimes. This is a very interesting thing because the pneumatic roof does not require a lot of, it will not generate a lot of forces. They've used it like a cushion. So the forces are contained to a very large extent. And this was a historical structure. So they did not want to touch the structure. And this roof is standing by itself. And it's temporary. So when the exhibition is there, they would put it up. And they do not destroy the historical structure. Similarly, retractable and deployable structures, these are very, like, far less common because of the technology and the maintenance involved and the expense. They are also expensive. So in this you can see, you can either just, if the weather is good, you can just retract the membrane, and when you need a covering, then you can open it out. This is another example of a retractable. This is from the office where I used to work in Germany, SL Rasch. So this was an expo, and this thing actually opens up like a flower. So in terms of design, this gave fantastic opportunities. Okay, so now I'll come to the technical parts of membrane structures, which is what we are here for, the steel. So if you see any normal structure, you think, okay, fabric is the main thing, but it's not the only thing. As you can see, a whole lot of the supporting structure is all steel, because eventually at the end of the day, all the loads must go somewhere, all the forces that are generated must go somewhere. And some members must carry those loads. So those loads in case of tensile structures are most of the time steel. So if you see the building parts of a membrane structure, you see that if there's a fabric, there'll be a border to it. And from the border, those forces will be carried and they will be taken to columns and stuff. Then there are area supports. There'll be some columns, there'll be some tie cables. Then there's a border support. So this picture shows very clearly what are the different details of. So you can see that in a fabric structure, you have columns, then you have tie cables, you have edges, seam edges, which need to be steel. Then you have the mast and the corners. So the design process, we already discussed that there's a architectural plans and then you have the structural system and then it's a back and forth process of design. But mostly after form finding. Form finding is the most important thing in tensile structures. Okay, so now I'm just going to now focus for the next few minutes, this is the second last thing, on the detailing of the steel parts of a tensile structure. So if you see here, the top picture that shows that, okay, there's that fabric. How does that fabric connect to the cables which are at the edges and which are carrying the forces and also giving tightness to the structure? So as you can see, either you can make one full sleeve pocket or you can have different kinds of connections. Then for the corners, you actually can, some of these parts are available ready-made, or you can make it to order. So the steel parts with bolts, can you see they are bolted? And then, but where this is coming, there's going to be a lot of load on the fabric, so it might tear. So you've done additional belt reinforcement so that it does not tear. So yeah, so these are just different ways. You can have the cable inside the pocket or outside the pocket. So this depends on you what kind of design you want, and also on the structural design. A very important component of membrane structures is cables, which is, I think apart from bridges, it's hardly ever used anywhere else in architecture. So cables can be many types, as we can see here. I don't think I need to explain it. So basically, we have to see, in the cables, we have to see what is the tensile strength that was required, that came in our structural analysis, and accordingly, we select a cable. But it's not just a cable. The cable has to be connected to other cables and to the other parts. So there will be all these fittings which will connect the cables, because the cables cannot be connected again, they cannot be welded, they cannot be screwed on, and they cannot be bolted, they cannot be done in the same way as we do our regular things. So these are the different fittings that are used. These are standardized fittings. So cables are there, and they are the ends. You can ask the manufacturer and you will get the ends like this. Again, these are edge details. So now you can see that, some of these people have used coated MS. So what happens over a period of time is, it's difficult to maintain that coating and they start rusting. And then it will erode the fabric also from that part. So if you use stainless steel, which is what we recommend, at least for these parts, then that rusting does not happen, it becomes virtually maintenance-free. And it lasts longer. So these are the support details of the mast, like it's connecting from the mast to the foundation. So what you do is that, if you can see this, when you lay the foundations, you put these base plates, and they have bolts, they leave them in the upside down this way, and then our fittings, they come and they are bolted onto it. That's a high point detail, because when you get a high point, again, the stresses will become very high and the fabric might tear. So just like when we make a waffle slab where the columns are there, we give a little extra. In the same way, we have to also reinforce this part. Okay, again, some edge details. So as you can see, why are they, some are wide and some are narrow? It basically depends on what is your architectural detail, how many points are coming in at that point, what is the shape of that point. So your base plate will be manufactured to match that. And of course, not to forget that the thickness of the plate and the strength of the bolts will be as per the structural requirement. So for the bolts especially, we always recommend, at least stainless steel, because bolts are otherwise very difficult to maintain. And bolts can become the weak point of your structure. Okay, again, another high point detail. So they're just like, depending on your structural design and depending on your architectural design, there'll be different types of. So basically the reason I brought in so many details is because I'm assuming a lot of you are architects or going to be architects. As architects, we normally think, acha, kapda laga diya, we put the fabric and now it's done. But actually fabric is just one small part of it. The steel structure is far more complex. Okay, so we use steel as a material because it's a strong material. It stays strong over time. It has high ductility. It's fast in construction. However, it's a little expensive, so some people get deterred. When you're considering stainless steel versus mild steel, you have to think of yield strength, corrosion resistance, cost, and aesthetics and stuff. So this is a comparative table. I don't know if you've already done this. Between mild steel and stainless steel. So we can see the tensile strength of stainless steel is far higher. So we can use thinner sections of steel for the same strength. Then corrosion resistance is very high, so it will last longer, which makes it more sustainable and low in maintenance. Even though the initial cost is higher, but the maintenance cost is lower. So as per the requirement and the budget and all, one can decide. So the weight, again, because it's stronger, we can use lighter sections, which architects always want to do. Then maintenance, durability, aesthetics, yeah. So of course, the aesthetics of stainless steel cannot be denied. Choice of materials, so it's, I think, just recapping what we already discussed. Okay, so now I've got a couple of case studies for you. One is, so about 35 years ago, I was working in Germany with a firm called Bureau SL Rasch. And a lot of their work is actually in Mecca and Medina. At that time also it was there, and even now they're doing all the latest works in those places. And they have a lot of other work in Saudi Arabia because those people have the money to spend on these high-tech tents, and the tents really go with the desert landscape. So this was actually the Prophet's Mosque of Medina, like the Prophet's where people go for Hajj, the Hajj Mosque. So they already had a structural grid of 17 meters by 18 meters, and they needed something, there's a courtyard, so they needed something that could be covered during the sunny part of the day or when it's super cold, and the roof could be retracted when it was pleasant so that the hot air could rise or whatever else effect they needed, the courtyard effect that we all know of. So initially our office gave them very low-tech and cheaper options, but Mecca and Medina being the important structures that they are for Islam, the king would always, give me something more expensive, give me something more expensive. So in this, whatever you will see gold color is all solid gold plated. In fact, I was there when some of the construction had started happening, and the king used to come every month to see. And we used to ask, okay, what did the king say? He said, yeah, everything else is fine, but could you add more gold here? So we had to think, okay, now where can we aesthetically add more gold? So they wanted something very high-tech and something that the whole world would look up to. ठीक है. अच्छा. I'm almost done. So these are the folding umbrellas. So what you can see is, you can actually see, these are the umbrellas these are the first picture shows the umbrella in a totally closed position, and then how it opens out. So it takes about a minute, I don't remember the exact time, for it to open. You can visualize the scale and all from it. Shweta, can you copy, paste this thing somehow? YouTube, I wanted to play the YouTube video. No, iska nahi bhi aage aayega. Okay, we'll play. No, not we'll this. Abhi, should I give you?
Yeah, show me the link and we'll send it over there.
Yeah. Wait. Just stop. This is the. Yeah. First two especially. Mostly first two. So these are the technical drawings for that folding umbrella. These are stainless steel arms. Hello? Somebody has a doubt? Am I audible? You can see, actually I was fortunate enough to be working on the working drawings for this, and I did full-scale prototype testing for this as well as another project. The technical data is a stainless steel structure. The membrane is made of open weave PTFE. Actually, for the membrane, the thing was that it had to be fireproof, because a lot of membranes are fire resistant but not fireproof. And Mecca being a little brother of Qum, the Hajj is a much smaller brother of Qum, in the sense there's a very large congregation of people, and if there's a fire over there, then many lives can be lost. So they have to make sure that the fabric is fireproof exactly. Because I think about 35 years or 40 years ago, there was a big fire in the tent city of Muna, and many people got killed. Okay, opening time is 19 seconds. The size is 17 by 18 meters. So that means one umbrella actually covers 300 square meters. So an umbrella may not sound very special, but when you visualize that the area under one umbrella is 300 square meters, 17 meters by 18 meters, like the size of this auditorium, I would say a little smaller than this auditorium, is one umbrella. And the height of it is almost 20 meters. And this just opens in 90 seconds. And these things that you can see are actually solar panels. The little strips that you can see on the top, they are solar panels. So they also generate the electricity that is required for the operation of these umbrellas. And for the water, since you can see the water would tend to get collected, it's an inverted umbrella, no? So the water would get collected in the center. So they have the water connection system and all is through these supporting masts. And the fabric that was used in these umbrellas was actually specially made in a, especially there was a lot of research done, and this company, Tinara, they made this fabric specially for us. Because normally the tensile fabrics, they're quite stiff, and if you fold it and unfold it over and over, there will be cracks and it will get damaged. So this fabric is a soft foldable fabric, and yet with the same tensile strength. Because the winds can, this has been designed for a wind speed of almost 150 meters, which is a lot, because वहाँ पे तो तूफान आते हैं ना, it's Saudi Arabia. You get these dust storms. Okay, this is another very special thing. It's not a tensile structure, but they are special retractable structures. So in the same compound, you can see that in the central courtyards, the जो पीछे दिख रहे हैं ना, those are the umbrellas, and these are sliding domes. So the way it is happening in these sliding domes is that, so you have this whole roof, and one part of the roof is covered, and the other part of the roof would be covered by the sliding dome when it slides over. But when they need to open it, it will open like this, and then the hot air can rise and the cold air can sink in at night or when the weather is good. So this is a picture of the prototype testing that we did in Germany. So I was there for this. As you can see, this is a steel structure, and the underneath of which there are these laminated timber panels, and outside is fabricated glazed ceramic tiles. Now this is a dome. So that means it's a doubly curved surface. So that means no hexagonal will fit there. Each hexagon will have a different size for it to look perfect in the geometry and the design. So they used to, what they did was, that time, 35 years ago, they had these CNC machines, and they fabricated these carbon panels, and the tiles were designed and printed on that, and this whole thing would come and be pasted here. These are the working drawings. I just happen to have access to it. Yeah, that's me, by the way, testing the steel structure. The motor, actually, it moves on 4 wheels. This whole steel structure, it moves. And we were testing the motors that day at the factory. The technical data for this is this is a steel frame. This is not stainless steel, though, because this would be way too heavy to be made in stainless steel. And this is not going to be exposed to weather conditions like rain and whatever, because this is totally sandwiched between the outer and the inner panels. So the size of the dome is again 18 by 18. And the opening time is 72. So the special thing about these domes is that it has 4 electric motors by which it goes. If one goes off, 3 will do it. 1 goes off, 2 will do it. If electricity goes away, they have a hydraulic jack. And in fact, here I was testing the hydraulic jack because then they said, if she can do it, anybody can do it. I guess that's it. But I have a couple of videos, if we can have access to it. They're just YouTube videos. If they want, sure, why not? That's not up to me or up to you. We are architects, we design for other people, and the client must want it and must be willing to pay for it.
So unless until they are aware about it,
I'm sure they are aware of it. I'm sure they are aware of it.
they are not. I am. You are really overconfident about our government people. They are not even aware about the usage of stainless steel.
So maybe you can take this initiative. I'll give you the details for this.
Sure.
Maybe you can take the initiative. Okay, so yeah, so there's nothing. They're just a couple of YouTube videos, very short ones, which I got from the website of that office. You will get any number of videos. I just try to take the shortest one. So you can see this is beautifully carved from inside with gold plating and Amazonite stone. Oh, this was amazing. And we had consultants from all over the world doing all that. So just look at even the design. It's not just the technicality of it, how aesthetics meet structures. This is a beautiful example of that. And so these umbrellas, see, one is high, one is low. So these are not in the courtyard, these are outside. So what can happen is that there'll be spaces between, so rain can come in. So they have one high, one low overlapping. to get full closure. So first the high ones will open just a couple of seconds before. This was the tent city of Muna. I think this is it. We can do the next one now. Can you please play the next one? And please keep it muted. So yeah, just go back a bit. Just for interesting thing, I'll just tell you that moon you saw, this thing is in Mecca. It's that courtyard where that thing is there, the black thing. And there's a clock tower that was made. And there's a moon on top that's made in gold-plated steel. And there are 5 bedrooms in this, which belong to the prince. And the highest livable room within this moon is higher than the highest livable room of Burj Khalifa. Just to give you an idea of the structural challenge. So SL Rash is the firm that I used to work with, still in touch with them. So if somebody wants to get in touch, those people are also still available. I'm still in touch with them. There's another one. There's one more.
We can also take some question answers from the students.
Yeah, sure. So in the meanwhile, if there are any questions? Did anybody find it interesting? Yes, no? यार कितना मैंने आवाज गला दुखाया कुछ तो बोलो At least I need to know that it's not going out and going up in thin air, na? It should be, I feel that very few people get the opportunity to even have access to something so special.
Thank you so much, Dr. Gupta, for such an interesting presentation on innovations in tensile structure and stainless steel usage in it. And obviously, we just saw the technological advancement in how evolving structure forms can be used, and presentation was very, very interesting and insightful. And now I can open the forum for question answer, and I'm sure you would be having so many. So first, introduce yourself, ask the question, and please address it to the speaker that you want the answer from. Raise your hand so that we can, yeah.
Hello. First of all, thank you for such an interesting session. I am Jaideep. I am from PSSR Group. We are a manufacturer of stainless steel pipes and tubes. So my question is for Rajamani sir. You mentioned the Chrysler building and you compared Chrysler building to Eiffel Tower, and you mentioned the Eiffel Tower was created using wrought iron and Chrysler using stainless steel, how it has had like a significant impact on the maintenance cost for both the buildings. So what all components of Chrysler were made of stainless steel? Were there any specific components, or was like the big part of the building made using stainless steel?
Any building needs concrete to be precise there, but all the structures and the facades that were used of stainless steel instead of normal carbon steel.
Okay, so the facades.
Yeah, the facades and the structures.
Got it. The rebars and.
Yeah, that's right.
Got it.
Any other question? Kindly raise your hand. You had brilliant 5 presentations. Yes, sir.
I am Susil. I wanted to know, because this was a very good presentation, but there are 2-3 things which came to my mind. One thing is that there was no comparison given that when you are using aluminum and you are using stainless steel. So what are the advantages you are getting? Because aluminum is a lightweight material, but it is also giving a good strength. Though aluminum does requires protection because aluminum oxide it generates. But when you talk about that you are coating a paint on stainless steel, so what advantage you are getting? Second thing that you are talking about the life cycle cost. Now, what is the cost difference with compared to the mild steel or galvanized steel? And what are the years it takes about to get the life cycle cost, and what is the initial cost difference? Because when you talk with the client, you have to convince him that why you are using this thing. The third thing is this, that when we talk about the coastal region or environment pollution, there is a sulfur, there is other pollutants which corrodes the steel. Now, there are zinc-coated steel is also available, painted steel is also available, and we are talking about the stainless steel. So, how much is the cost difference in between them? The second thing is this, that reinforced steel has the very good bonding with the cement concrete. Now, when we talk about the stainless steel, how much bond it has, because even if you are using tor steel, so in that case, how much bond strength it gains. So these are some of the questions. If you can put the light on this thing, that will be helpful. Thank you.
Thank you, sir. I'll take up this question. In yesterday, day one, we had a detailed presentation. I'll take the question backwards, since so that I remember the last one first. So yesterday there were presentations made by some learned speakers about reinforcement bars in stainless steel. Sir, this is a very common misconception that bond strength of the stainless steel probably will be lower because of imagination that there is a shiny surface and it may slip with the concrete. See, if you look at both the codes, for TMT, there is a code IS 1786, and for stainless steel, the IS code is 16651. Now, if you look at the rib geometry and the dimensions of the geometry and the other parts of the geometry, all the formulas are same. So, apple-to-apple comparison is there. If you do a bond strength test, it is stainless steel and steel both are equally good. There is absolutely no difference or lowering of the bond strength because of the stainless steel, because the surface of stainless steel is not what you imagine is shiny. It is pickled surface, which still have a rough surface, and bond strength comes from the rib geometry. Most of the bond strength. Now I'll add it further that TMT generally after the passivation lowers due to carbonation in the concrete, because concrete is porous. So then the corrosion starts happening after certain, maybe a year or 2 years, depending upon the environment. The moment the corrosion starts happening in the TMT bars, the carbon steel ones, and the reason why so much of failure happening and spalling happening, the bond strength starts reducing. But if you have protected TMT, in our case it is stainless steel, you have a long bond strength intact for a longer period of time. Now, your second question, I'll answer it with respect to TMT only. So, there can be zinc-coated TMT, there can be epoxy-coated TMT. So, you are doing certain corrosion protection over steel to make it last longer by incurring some additional costs. Say, if X is the cost of, I'll not go into exact rupees, but if X is the cost of steel, then you put 1.2X for, say, or 1.3X for galvanized, and then you put 1.6 or 1.5X for epoxy coating. So if you talk about stainless steel, the basic stainless steel from where it starts, because in the standard there are many grades of stainless steel. So the basic stainless steel where it starts, it will be 1.8 times to say 1.8X or 2X, and then it can go up to 3X, 4X, and there are probably some duplex stainless steel will be somewhere around 3.5 to 4 times the cost of carbon steel. So there is a wide data available with respect to how the performance measurement. So zinc coated, yes, it performs better than carbon steel, but then there are some thresholds, like say if it is a chloride based pitting corrosion, then there are some thresholds. Some of the lacuna in other coating or say some kind of protection method is that at the site, if you, I gave 2 examples in my presentation about the roofing. I made that example. The moment you are bolting a roofing, then you are creating a notch there, or say creating a surface where the coating has gone off because you have cut it and put a bolt there. Now some crevice corrosion will happen. Slowly the corrosion will start happening, and the roof where the fastener is attached will become loose from there, and due to wind pressure it will further create stresses. And since there are notches, it may the stress may transfer, and slowly over a time it may tear off. And that is why, because those 2 examples which I gave, the cyclone Fani, the Hudhud in Vizag and cyclone Fani in Odisha, where all the airport roof structures teared off. So that can be one of the examples. So as Rajamani sir said in his presentation, that there are a lot of other sustainable materials which are good, probably we are better at times with respect to cost, but then life cycle cost, if you calculate the life cycle cost in true sense, not just by adding 3-4 things. In true sense, if you do the calculation, it is always advantageous. There is enough data available, we can share it with you with respect to time or with respect to environment. Like you mentioned sulfur, you mentioned some other pollutants. So there is enough corrosion data available, and yes, other materials also perform well. Last, you said about aluminium. Aluminium at times is also good for architectural application, but there are issues of corrosion, that is okay. But as far as strength goes, yes, stainless steel performs far better. There are two good reasons is yes, strength is higher, but there is also impact strength, fatigue strength, creep strength. There are many types of load, the cyclic loadings are there where stainless steel performs better. So if you take a holistic approach on mechanical properties, then stainless steel definitely performs better. But yes, in terms of heat transfer, heat conduction, and probably lightweight, where you have to carry some large sections, or sometimes aluminum is also lighter in that sense. But it's a comparison of metals and your choice, depending on many factors. Thank you. Hope I have answered your question. Thank you, sir.
One more thing I would like to add, what Rohit said. He fantastically briefed all your points. When we compare the cost of stainless steel vis-a-vis other materials, we compare the material cost. We are talking the escalation on cost is only for the material cost. But if you take the project as a whole and a holistic way, for example, on a project of 100 CR, where your other parameters going to be constant, like concrete and every other thing. Just you are replacing the materials with stainless steel with the other conventional material. That itself is the 20% escalation. But if you put it on a holistic way and the project cost, if your project cost is say 100 crores, and if you are replacing that with stainless steel with other conventional materials, the cost escalation is not more than 3.5 to 5% maximum. So rather than spending 105 crores and getting a life cycle span of more than 100 years is much, I think, wiser decision rather than going for a material which is going to last for only, say, 15, 20 or 30 years maximum. Thank you.
Any other question? Yeah. Could you please give the mic? We have 5 more minutes, so we can...
Hello, myself Rahul. I am a PhD scholar. My question is related to Indian Railway tracks. So for dedicated freight corridor, that is ongoing process. So what is happening? We are importing the track material from Japan. Because currently what the Indian Railway tracks are, they are being done by SAIL and other companies. So the axle load that is being calculated, so it is less for the Indian companies. So that's the reason they are approaching Japan for having a more axle load for the DFC corridor. So my question is, why can't we have have the more strength material within India, Indian companies for that? So this is one part of the question. Another question is, can we have such stainless steel material for the wagons that can be tolerant to cutting from the gas cutter, for preventing the crime? What is happening, the criminals are approaching the wagons and then they cut the metal very easily and they access the goods, so they steal it. So is it possible to have more strength material?
Rahul, whom do you address your questions to?
It could be Mani sir or Rohit sir.
Thank you that you have asked this question. I am very eager to explain it to you. The second part where you talked about wagons. In my presentation, I showed you the blue color wagons. Those are made in spherotic kind of stainless steel, which is a utility and moderate corrosion resistant stainless steel grade. See, I'll come to the cutting part. Why you need a stainless, a wagon axle load? We have rightly talked about the axle load. So you need high strength material to take greater load, which should be lightweight so that you carry more material into it in the same axle load category. So long back, these wagons were chosen in grade of stainless steel. And slowly, in most of the, wagons can be of box NHL, box HL, and so many varieties, open wagon, closed wagon. So the open wagon which carries coal and other minerals from different locations to our country, to plants in our country, especially in coal wagons, you will say all those are in blue color, because what is needed was there should be a good slidability the moment you are lifting the coach. So good slidability should be there. So stainless steel is good in sliding wear. So there is a erosion, corrosion happening there. And also there should be less of the maintenance due to damages. So if you have a high strength material, then obviously the hydras and everything coming and taking material out of it, there can be structural member, the load on structural member, impact load, or on the bottom which can tear off the bottom. So for all those reasons, stainless steel was chosen by Indian Railways. Now to your question about cutting, can it be, it should not be easily cut or maybe destroyed or dented. See, this is exactly the reason why Railways has also gone forward with it, because stainless steel has chromium in it. It cannot be oxygen cut because it is not. The right method is to do plasma cutting and some other cutting method. And the material which they have chosen has a very good spring back effect. If you try to put a dent into it, it is very difficult to get dented. So for all these such good properties, those wagons are perfectly running fine and better than cotton steel for that reason only. Now coming to the track part of it, where you said that probably in some dedicated freight corridor. See, we are from stainless steel industry, not from the steel industry. So, but I have some awareness of it. So, if I may not be 100% correct, but let me give you some feedback on that. The rails are produced in our country by other bigger companies like SAIL, JSPL, and others, which are being used. Probably some section of that corridor where some material might have been outsourced, I'm not much aware, but stainless steel is not used for rails. It is only steel, a certain grade of steel is used. And I truly believe that probably this is already being done in our country. So I'll explore more if I know about it.
See, I have a carbon steel background, so I can address you this particular question. See, there is nothing that India can't do. India can do that. The only thing is, is there a market for it first? Because we, unlike the Western countries, we don't do research, spend money on that. We always want something which is the market is readily available. So we don't invest on, researching on a particular product, then patenting it, and then marketing it. We do it now. It has started. But, if you compare it with the Western countries, it is not at that particular scale. Point number one. Point number two is, if I've done it, where is the protection for the market? If you see US, they have suddenly put a section 232 of imposing 25% duty on all the products across coming from all other countries, protecting the domestic industry. Then you have anti-dumping duty available, in US, which is running for almost 25 years, 30 years. And if you see the duty percentage, you will be absolutely wondering, what's wrong with that. 579%, 683% in steel. Whereas to put a 20% duty on our product protecting the domestic industry, government is slightly, they see all the WTO compliance and all those stuff. So unless and until there is a protection, now it has started coming in that Atmanirbhar Bharat has come, Make in India initiative has come. So these have come, so this was not there earlier. Now it has come. It will take some time to get it. Otherwise, India is much more capable than doing any other product in today's scenario, because technology is available at a price today.
Yeah.
Thank you.
Is there any restriction for the track, like why we can't use stainless steel tracks instead of like carbon steel, apart from the cost part?
See, cost itself, and there is no much players. If you look at it, nobody thought about that because it is running on this thing. When something is always on a use, then corrosion may not happen so easily. When you leave it aside for some times, then corrosion starts happening. So, and moreover, the cost will kill you. Leave about other things, the cost will kill you. And India is not in a position to take. In fact, nowhere in the globe, where stainless steel tracks have been laid. I don't know. I think, Rohit, it's not there. There is no practice actually.
Yes, sir.
Yeah, we may wind up. There was a question that lady was asking. This could be the last question.
Thank you very much, ma'am. I'm Harshika Sharma from second year. I have a question regarding how we can use stainless steel in climate responsive architecture, because Dipti ma'am has done the research in Makkah Medina that they have done a good job in doing a umbrella shade for the courtyard for people to offer their prayers. But since we are also learning about climate responsive
Sorry, can you please
architecture,
just repeat? I was not paying attention.
Sorry. So I have a question for you, that how stainless steel can also be used in climate responsive architecture, because we are learning about sustainability. So I want to know how climate responsive architecture and stainless steel can be used in it, because
I think I just gave you an example, right?
yes, ma'am, in various, since we are in India, so I wanted to know how in India we are having so many climate zones, so how we can use in each and every climate with a little bit brief.
Actually, this umbrella, the retractable structures are very climate adaptive because they change. The structure changes with what your needs are.
Okay.
And as far as climate responsive architecture goes, I think you as an architect has to first come up with solutions. This is what I want done, and then you have to choose which material can I use. You can't say, oh, I want to use stainless steel, and then now let me make a system which uses only stainless steel. That's not the right approach, I would say. I would say, okay, then they said, okay, we want to make retractable. First, they gave very low-tech solutions. But then they said, no, we want high-tech solution and more permanent in nature. So, okay, steel, then the fabric was developed, the technology was developed. It was not existing before. That technology was developed especially for that project. But that project had a lot of funding, but now the technology is there. Now I've shown you retractable structures of all kinds. So I think retractable structures are a very good solution to adaptive or climate adaptive solutions. This is exactly what it was. But if you have some other solutions also, I'm sure if metal is needed, you can consider. I'm not one person who pushes one material over the other. I'm not from the stainless steel lobby. I'm an architect.
Stainless steel has a lot of grades. There are more than 100 grades are there, and each grade is having its own property regarding corrosion and strength and everything. So depending on the different climate condition, you can select the grade.
Okay, sir. Thank you.
Thank you so much for such an insightful, enriching session on innovation and in architectural design. To me, I would say that all the three aspects of design thinking, whether it is observation, technological advancement, or design specific, or user friendliness, all the five speakers have stressed upon, and what is the material suitability, and the idea is to have innovations, those are viable one and leading to sustainable future. So I'm handing over to the organizers, and thank you so much.
So instead of generic, since the two examples that I showed you, I have personally worked on the working drawings of these, the design process, as well as I was fortunate enough to test the full-scale prototypes. If anybody actually has a question on those projects, I'd be quite happy to answer. Maybe now or over lunch.
Yeah, you can meet all speakers over lunch. Thank you.
A very big thank you to ISSDA and to our esteemed speakers. Thank you so much for enlightening us. You almost made steel. Okay. Can I take this instead? Is it better? I'll need. Okay, yeah, thank you so much. And thank you for giving such a humane dimension to steel. Steel, which is otherwise... आप ले जाइए इसको. Yeah, so such a great humane dimension to steel. Steel almost seems like a human being. You know, we as a group of people are just Homo sapiens till we have value in us. So chromium in steel makes it stainless, gives it strength. Thank you, Mr. Rohit, for telling us this. So thank you, Mr. Nagendra Vijay. You told us how, reminded me of the story of milk and sugar. Sugar, when mixed to milk, does not, it doesn't assert its presence. It just mixes with milk. Similarly, steel, when water pipes are formed out of steel, it doesn't corrode the water. It actually enhances the water. It doesn't, doesn't tamper with the water. It enhances the quality of water. I think this point was mentioned by Mr. Rajmani. And there was another story where the steel, when it is integrated with heritage structures, it only enhances the strength of it. It doesn't assert its presence. It doesn't say, here I am steel, but it just mixes with it, and it makes the structure stronger. So thank you so much. Thank you for your insightful things. And Dr. Deepti, thank you for talking about collaborations. Alone, steel cannot be what it is, and fabric cannot be what it is. Only when they come together that they can form these amazing structures. And with that, I would like to invite Mr. Sanjeev Sood and Professor Anil Devan onto the stage to felicitate our speakers. May I invite Mr. Rohit Kumar, Executive Director of ISSDA. Mr. Nagendra Vijay, Consultant for ISSDA and Ex-General Manager of Steel Authority of India. Mr. Rajmani Krishnamurthy, President of ISSDA. Mr. Monik Parekh, Deputy General Manager of Raajratna Metals Limited. Dr. Deepti Gupta, Principal Architect at PNG Architects. And finally, our moderator. Thank you so much, Dr. Pooja Gupta, ma'am, for doing this for us. Thank you so much. Now we all can proceed for lunch. Thank you very much.
or aesthetical, but also environmentally responsible. So the circular economy is central to this vision, promoting resource efficiency, waste reduction, and the continual reuse of materials. Today we have 4 distinguished speakers who will help us understand how to incorporate these principles in real estate and architecture. They all come from the diverse backgrounds, each bringing unique perspectives on materials, innovation, and sustainability. The 4 speakers are architect Anjali Shukla, architect Kunal Mathur, and Professor Anil Devan. And we have with us the moderator for this session, Mr. Sanjeev Sood. I request all the speakers and Mr. Sanjeev Sood may kindly come to the dais. So now I would like to introduce Mr. Sanjeev Sood, the moderator. Mr. Sanjeev Sood had been at HSCC as the chief consultant in architecture. He has joined HSCC in 1984 and served as the head of the architectural services since its inception from 2015. Mr. Sood graduated from CEPT Ahmedabad and did his post-graduation from Architectural Association London, UK. He worked in the offices of Kanwinde, Rai, and Chaudhry in Delhi and Tehran. He was involved in the seminal Sher-e-Kashmir Hospital in Srinagar. From 1984 to 2010, he was as the head of architectural wing at Hospital Services Consultancy Corporation and was full-time consultant to them till 2015. He had been responsible for a very large body of public work in India and abroad. Some of the major projects, to list a few: AIIMS Trauma Center Delhi, National Cancer Institute, AIIMS Jhajjar, OPD AIIMS Delhi, besides the hospitals in Mauritius, Nepal, and Sri Lanka. His innovative and efficient projects encompass a wide range from complexes to individual units. We welcome you, Mr. Sood. And now I would like to hand over all the stage to Mr. Sood.
Begin with Anil Devan, Professor Anil Devan. He is the former Dean of Research at the School of Planning and Architecture. and an active member of various building works and committees at AIIMS and similar institutions. He also serves as guest faculty member at AIIMS, IIMs, and other leading academic institutions. So I now hand over the mic to Mr. Anil Devan to make his esteemed presentation. And I've known him for a long time, to add.
So, welcome to the post-lunch session, and as it was said yesterday, there'll be a lot of repetitions. So, but maybe let me talk about sustainable design in healthcare, which means where is the use of stainless steel in healthcare applications. So, if you so my presentation is first use of stainless steel in buildings. I think I'll skip that because that is actually repetition. It's been said before. And then, okay, in medical field, what happens? The medical equipment, the medical furniture, which is the fixtures, the elements and supporting systems, they have a lot of stainless steel. And then I will come to what are the benefits of using stainless steel or steel, that it's more hygienic, it is durable, sustainable, and cost effective also. They've been talking that if you see the life cycle costing, then it is cost effective, but if you see L1 costing, then it is not cost effective. So we have to change the mindset, and we have to come to life cycle costing of buildings and fittings and fixtures and furniture in that. So I would then talk to you about operation theaters, ICUs, the service areas like CSSDs, kitchens, mortuary, laundry. These areas we have a lot of stainless steel. And then challenges and eco-friendliness and limitations and costs. And then about future scope of these materials. So there are different grades of stainless steel that they've been talking, and there are some samples outside there, and there is how to join them and how to fix them. All those things are also there. So the different grades of stainless steels used in hospitals are these. I'll leave my presentation with you people. I'll share it with you so you can study it later. So what happens is that, so there's stainless steel, there's mild steel, there's aluminum, and there's copper. These are the competing materials. So there is this infection control in hospital, and infection happens through human touch, which means from a caregiver to a patient. But when you touch one material and another person comes and touches that material, then also infection passes, and infection passes through air also. So we have airborne infection, and we have infection that is from material. So the building professionals have a role in the materials which we touch, and then another person comes and touch. So copper, they say, has antimicrobial properties. Aluminum is good, but it doesn't have these properties. Mild steel is very strong, but it rusts. So stainless steel is rust-free, it's easy to clean, it's strong and long-lasting, but then its cost is a little higher, and the maintenance is low. So you see the advantages and disadvantages. So the various grades of stainless steel, they've told to us in the last session also that there are maybe 100 grades of stainless steel. But what we know of is 304 and 316, and in which also there are various classifications and categorizations. So let the experts talk to you about those. But what I have to say is that stainless steel has been used traditionally for dental, surgical, reconstructive, and other purposes also, which means all these needles and these cannula and pins and all these materials also have a lot of stainless steel, and the advantage there is very well understood by all. Then these medical equipments and instruments, the surgical tools, scalpels, forceps, scissors, syringes, needles, and orthopedic implants, prostates, dental instruments, all these are stainless steel. And then hospital infrastructure and fixtures, the bed frames, the stretchers, the wheelchairs, trolleys, railings, handrail, all these DMRC or the metros, their railings, handrails, grab bars, door handles, push plates, they are all stainless steel. Maybe here also, if you see, you find them stainless steel. But when we come to operating rooms and ICUs, the surgical tables, trays, trolleys, instrument, sterile work surfaces, ventilation and HVAC ducts, and our modular walls are all stainless steel now. So, the autoclaves, the sterilization containers, the wash basins, the sinks, the waste bins, and the biohazard disposal units, they are all made of stainless steel. And in the kitchen, in the pantries, and in the food service areas, in the trolleys which carry the food, they are all made of stainless steel. And even our refrigerators in there are stainless steel because it's heavy duty and it is to be cleaned and it has to be infection free. So now, plumbing and sanitary systems, the piping for water and medical gases, ideally should be also stainless steel. And the sanitary fittings, the drains, the faucets, and the shower heads are stainless steel. But we see a lot of stains on them. Maybe the stainless steel to be used is not the appropriate one, or the maintenance or the cleaning is not done properly. So the lab benches, worktops, chemical storage cabinets, fume heads, and exhaust systems are also stainless steel. So now, in this slide, I show you the hygienic and sterile property of stainless steel, which is it's non-porous, corrosion resistant, and easy to clean and disinfect. It is eco-friendly because it's recyclable, long-lasting, low maintenance. And it's versatile, ideal for medical equipment, storage, and infrastructure. It withstands chemicals, is high return on investment. Cost effective. So there are these non-magnetic properties of stainless steel. In our times, they would bring a magnet and show it to us that this is stainless steel. Impact resistant, fire resistant, and it takes the form and it takes any shape and any type of surface can be made. So now these are modular OTs. This is an old OT image. Now the OTs are not all that much of clutter. We have these pendants. So stainless steel walls and panels create a seamless environment, and we have this pendants from top, so the floor area is free for the caregivers and the surgeons and the anesthetists and the circulating nurses to move around. And they do not absorb any moisture, reducing the risk of these microbes, these viruses and bacteria to grow there. So applications of stainless steel in hospital OTs is in wall and ceiling panels, in scrub sinks and storage cabinets, OT doors and pass boxes, sterile workstations, and equipment trolleys. So similarly, in our CSSD, all these back of the house service areas which are very critical for infection control, and where no patients and public comes, are all stainless steel. So the CSSD is very critical, very important for the surgical instruments to be sterile. All this area is stainless steel total. So it reduces the risk of cross-contamination and hospital-acquired infection. That's a very serious problem we have in this country, because the manpower, the people, they are not trained properly, they are not sensitive, and they cut corners. And thus, we have a lot of hospital-acquired infection in our country, which could be reduced by use of stainless steel in these areas and very proper procedures to be followed by the manpower working in the area. There are strong SOPs and they should follow the protocols, and then we would have a very sterile, clean environment. So there are high pressures, high temperatures in these areas, and stainless steel can take all these harsh environments very easily to make instruments clean. So then we come to laundry. Laundry also is a similar situation, and even in kitchens. Kitchens I've told you, but these are examples of how you can see it's almost all these are stainless steel. So it withstands exposure to water, steam, acids, cleaning chemicals without rusting. So all these things are there, and there are high cooking temperatures, and it is fire resistant, and it's resistant to stains, easy to sterilize, and with hospital grade disinfectants which can be used. So cooking equipments like ovens, stove tops, food warmers, workstations and countertops, sinks and dishwashers, refrigerators, freezers and storage racks and cabinets, they are all made of stainless steel. It's almost, so similar is the case with laundry. All these washer, dryers and all these equipment which is used in the laundry, they are taking very heavy loads. They work almost round the clock, and they have high-speed operations. So they also are made of stainless steel. So in laundry, the machines, the tubs, the sorting tables, storage racks, trolleys, carts, shelving units and drying racks, they are all stainless steel. So mortuary is it has to be so good that the workers who are working there and the doctors who perform the postmortems and autopsies and all, they should not get any infection. So we have stainless steel storage units where the temperature is maintained and body fluids and harsh chemicals and disinfectants are there. So the body storage chambers, the dissection tables, autopsy tables and trolley systems are all made of stainless steel. So these autopsy tables and where the procedures are carried out and the storage units, they are all stainless steel. So the faucets, the ventilation systems and the mechanisms are all stainless steel. So in future of hospitals, we say we will have smart hospitals, smart things. So all these will have sensors, and where we could do contamination monitoring, sensors to detect bacteria and alert the cleaning teams, self-sterilizing technologies enabling UVC light disinfectant surfaces automatically, and integrated HVAC and air quality monitors, temperatures, humidity for better patient recovery, and touchless interactive gesture control reduces the physical contacts and improves hygiene. So this is all I have to say in the use of this material in hospital settings. Thank you. I'll take the questions later.
Thank you, Professor. I would just like to add 1 or 2 points to what you've said. Your presentation is very insightful and looks at the use of this material in hospitals. It elaborates the use of this facility. Major contribution of this material to the user sustainability of the facility. This is one of the major issues concerning material and how it is used. And this is what the elements that he has identified are the areas which should be the focus in addition to various other facilities. Now I would ask Anjali Shukla to make a presentation. I've just introduced her. Carry on. With nearly 25 years of experience, she is a practicing architect who believes that architecture represents the perfect blend of art and science, offering a comprehensive understanding of human habitation and behavior. Traveling has been her greatest source of inspiration, influencing her designs, writing, and teaching. She's taught as visiting faculty member at various institutions and is a strong advocate of experiential learning. She believes that learning architecture can be visual, immersive, and sensory experience that leaves a lasting impact. To support the philosophy, she has maintained a teaching office within her practice, regularly mentoring student trainees. Studio 9491, her architectural and specialized design firm, is a collaboration with Raman Shukla. Together, they have led numerous projects across various sectors, including retail, residential, commercial, and hospitality. Their clients include renowned names as L&T, JSL, Terry, Ansels, IREO, Benetton, KFC, ITC, Wills Lifestyle, Unitech, Indian Air Force, and the Rajiv Gandhi Foundation, amongst others. Thank you.
Before I begin, I would like to thank the organizers for this amazing event that you all have put together. And more than anything, the guests you have invited, they have inspired me right through from the beginning. They are senior to me, so I'm humbled because it's just amazing to listen to these experienced designers. And you know what's the most beautiful thing? It's the kind of enthusiasm and passion that they still have after so many years. For me, that's a very big takeaway. So thank you so much for thinking of including me in this star guest list of yours. My presentation is totally centered on understanding what material means to a designer. So actually it is addressed more to you all students, because the rest of the star guest list here, they've been exponents of using materials in a most magnificent way. But today I want to leave a little seed with the students of what material really means. And I would like to start, I have 2 parts to my presentation. One is to understand the concept of sustainability. So like Sir said, there's a lot that has been said, and definitely there will be repeats, because there is this one very simple message. It's a simple core message that is very important for all of us to understand. Yesterday there was this amazing thought that came from one of the speakers to say that sustainability actually is something that our Indian culture is completely rich with from the beginning of where we started. It's nothing new actually for India. Like a lot of things are coming around and we are realizing that they are more Indian than anything. They're coming back from the West, but they're actually, the birth is in India. Similarly, sustainability, I also believe, is something that is very, very intrinsic in our culture. This image that you see behind you, in day-to-day life, going many years back, this is also sustainability, where we eat fresh, we make fresh, and try to minimize our garbage. Garbage is something India never created before Amazon came, not this much. So sustainability begins with these day-to-day activities that we have undertaken. Be it the Kullhad wali chai or this pattal that you eat on, these are all traditions which India is rich with. Again, something that was mentioned beautifully by the same gentleman, which I totally resonate with, that using material and repurposing it and reusing it is something that we Indians are very good at. And this still exists. So the first sari that is bought is passed on to the daughter. Once not wearable, it is taken up as a project of reconstructing, repurposing. And if eventually it does not even end there, and it ends up being used till the last bit of it is not usable. It may seem like a very simple thing, but sustainability begins there. And from this small seed to take it to a larger picture is what we architects and designers have the capability of doing. Sustainability is also an understanding of nature, a respect of nature. And I think there is no better example than our pure art forms, which come from the tribal painting to the Varli art, to all kinds of art forms in India which are completely inspired by nature. So sustainability for me is also resonating with nature, understanding nature, because if you do, there will be very few times that you will consciously at least step out of the boundary of respect for nature. So again, a very, very, very easily understood thing. All our festivals are based on nature, whether it's the movement of the planets, movement of the moon, or the season of harvest. All our festivities are based on that. So again, we understand this very well. Nobody really needs to tell us all these things until date. And I'm seeing you youngsters, I'm so happy to see. I have children around your age, and so happy to see you all coming back, coming round and listening to the songs which I used to listen to, or maybe older, maybe before I was born. It's not just about that song, it's about an understanding, a sentiment, a connect back to the roots. So sustainability as a concept of Indian culture is very easily understood, like I said. The confusion begins here, especially for a lot of the old education, which is architecture is one of them. It's one of the oldest professions, am I right? I mean, it's been there time immemorial. Even the Egyptian pyramids needed an architect to make them, right? So the confusion begins here, where in our architectural education, our exposure becomes a little limited to the references from the West. So when we were called in to do a project in Lucknow, I felt terribly ashamed that I didn't know enough about Lucknow at all. We were not taught enough. I knew about Rome. I knew about all the monuments there. I knew about the perspective correction and the way the Romans designed. I knew about the first concrete that was poured in Rome. I knew everything, but I did not know anything about Lucknow, for example. So modern architecture, this is a little thing you all must understand where it's coming from. It's really not our fault. It's the way we have imbibed education. Modern architecture, what is modern architecture? Modern architecture basically is talking about taking all references of context away. Again, great masters, great work. We cannot take away from any kind of good work that has been done in the past. But there is a slight robbing of context or understanding of context. So modern architecture, the Bauhaus movement, all of you have read about it, yes? You all are familiar, yes? History of architecture, history and modern history of architecture, everybody understands where this started and who were the exponents, right? That is where the confusion actually began in a lot of us. Alongside the modern movement, however, there were people who were thinking differently, both abroad and in India. Like I said, my references were all from Western books about Western buildings. So obviously, the people before me were completely flooded. So the founder of the college where I'm from, Professor B.V. Doshi was the founder. I'm from CEPT. He used to tell us that all we learnt about was about buildings from Europe, right? I have a niece studying in America right now who's also saying education even now is Eurocentric. So obviously, the questioning of modernism never happened, right? I find this very interesting as a concept. An article I read by Kenneth Frampton when I was studying. It was about a concept of critical regionalism. Has anybody heard about this concept of critical regionalism? So I'll just read a little excerpt from the book because it is actually the crux of understanding what I'm going to say. Kenneth Frampton said in his book that the phenomena of universalization, while being an advancement of mankind, at the same time constitutes a sort of subtle destruction, not only of traditional cultures, which might not be an irreparable wrong, but also what I call, for the time being, the creative nucleus of great cultures. That nucleus on the basis of which we interpret life. What I shall be calling in advance the ethical and mythical nucleus of mankind. So this was recognized very, very long back that there is something amiss with modernism, right? Like I said, there were a lot of great architects, and only to name just a handful, who stood up and understood this problem at the onset itself. Architects in India and abroad. In India, the gap was more glaring because what we were at that time was a very, very poor nation with very limited resources. So when the modernists came, for us, it was, yes, an awe, but at the same time, a complete subservient attitude to our own culture, our own civilization, our own inspirations. Hence, you see what we are seeing today. There is the presence of these great architects, and of course, you know two of them well, but also architects like Eero Saarinen and Tada Wando, who stood up and talked about critical regionalism way back then. From critical regionalism, I coin a term called contextual design, to understand context. These are few pictures of a building in Delhi. I don't know if everybody recognizes. I know my contemporaries and seniors would. This has been done by a gentleman who is actually from America, from USA. So imagine that his cultural roots are in another country, but when he moved to India, there was a complete understanding of where he was building, what he needed to do, and which links me back to material. I think he's one of the people who I've observed closely because I trained with him. I have, a lot of links with his office and his work. He was a person who understood material, and I deeply appreciate his work. Mr. Joseph Allenstein. So the question to you kids is, if you are attentive enough, on the left you see a building, which is an office building. I hope you recognize this. And on the right is a new building, which has just been unveiled. So while I was driving past it, it was a little shock to me because I was like, it had the scaffolding on and it's just been removed. This is the new World Trade Center, right on Ring Road, Naroji Nagar. So when we can build like the image on the left of you, why are we building like the image on the right? This is a question to be posed to people who are in power, who are in the government, who are designing these kind of buildings. Why are we building like this? I'll take you through a couple of slides now of a project very dear to us, which we have just finished, just to tell you of the struggles that designers today are facing, to be able to connect with this question, to try and work within a framework which connects with this question of why are we building like that. Indian architectural sensibilities are an absolute treasure. I don't need to even expand on that. But yes, we are not talking here about making arches in your building or copying from old buildings. That's also happening. Personally, I don't align with it, but I am talking about understanding the essence of Indian architecture and taking inspiration from that. When you see the images on your right top, it's a very familiar image, right? You would have seen this in a lot of monuments. And you all definitely would know, because you're all much more aware than I was at your age, that why so many squinches are made to create an arch or a dome. One is geometry, to be able to create the structure. But on the facade, they have a very different role. The surfaces, when broken, absorb much less heat. There is mutual shading. So apart from the fact that we like the aesthetic, it's timeless, ageless, it looks beautiful, there is a very deep scientific reason for this. So we kind of took all these inspirations when we discovered Lucknow on our own and tried to translate it into the building that we designed there. It was a hotel we've done there. So the building imagery that you see on the left and the bottom are completely different when you look at them. Somebody would ask, what are you talking about? But yes, an architect and all of you architecture students would understand what I'm saying. We have simply broken the surfaces of this building rather than designing a hotel which is a blank facade completely, which most of them are. I don't know why. We tried to break the surfaces of this building to be able to get mutual shading. So that's the west facade on this photograph. I was just mentioning that I was so upset that I didn't know much about Lucknow. So we requested our very gracious client that 3 दिन हम लखनऊ घूमेंगे और 3 दिन सुबह 9 बजे से रात के 9 बजे तक. And the beauty was he came with us. He was from Lucknow. He was so happy because he said, मैंने लखनऊ ऐसे कभी नहीं देखा. So literally we were like kids, like, you know, maybe doing a study tour. And we loved it because we went and saw every space in Old City. We went to the residential areas. We went to the monuments and gathered all these inspirations which you see on the left and maybe created something what you see on the right. It's a reception table that we've designed. Completely different, but there is some soul we tried to extract from what we saw in Lucknow into the work that we did. Sorry, just a second. Once again, a lot of inspirations, a lot of forms. Without directly taking it as a copy, we tried to put them. So the bridge that you see here is from an old building in the Old City. And here's what we did to adapt it. So once again, a humble attempt at something that could respond to where we are, something that could be inspired to where we are. Completely modern material, straight line. But we tried that there's a soul that comes in from Lucknow. Another thing which is a very important part, and it ties in with the material inspirations, is understanding old technology of building. We are losing it completely. And I understand, yesterday beautifully summarized by the senior people here, that we have to move fast, we have to build fast, we have to create something really in a less time. But certain technologies, if we could explore and bring them back, it's actually not that difficult, you know. So in Lucknow, again, once again, it has a very rich tradition of terracotta work. And the sad part is all the labor and craftsmen of terracotta are out of work. We had to literally pull people out, commission them and give them work because they had no work and they were bankrupt, all of them. So we created, it's very, you know, it's a thing that was done in the past, insulated roofs. So we created these ceilings. We actually had to get terracotta pots from Kerala to be able to make the artisans there understand the kind of pot we needed. But we did it, and we said, no, we are going to do this, and let them make the pot the way it is to be done for this technology. As a result, engaged a lot of craftsmen who were out of work, women who were out of work. Women are very good at this, and women who were out of work, they came and joined in. And that's the construction photographs of the slabs that you will see now. And that's what the top floor of this building looks like. Of course, like I said, I repeatedly mentioned, you need a very sensitive and trusting client. And I'll touch upon how you do that as well. Now, contextual design and context and understanding is very critical to design according to us where we stand. And everything is to do with materials and understanding materials. Now, you all must be wondering how it ties back to stainless steel. So sustainability, circular economy, building something that belongs to where it is, and then this material, which at the outset sometimes seems completely disjointed. I mean, we are here talking about context, we're talking about earth materials. India is all about earth materials, right? We're talking about stone, we're talking about brick, and then stainless steel. So that's where it gets very, very interesting for us as design professionals. So I'll share two quick anecdotes with you. So this is a photograph of Run of Kutch, Gujarat, where they have these circular huts that are there. And we went on a study trip, and it got really dark. We had to stay over in that village, which was on the border of India and Pakistan. So quite an exciting experience at that time. And the chief of the village, this was a village of 7 huts, that was it. That was the whole village called Dhordo. And the chief of that village said, "Aap hamare ghar mein rahiye, you come and be our guest." We entered his house, and this is what we saw. That the most precious decoration in his house was his stainless steel utensils. Cut to a trip I made as a young girl to Chennai. And we were told we are going to a supermarket, and we ended up going to Ratna stores. And when I entered, I literally screamed and jumped out to see the site that you see in the middle. That's a photograph of this store from inside. Once again, stainless steel. And in Tamil Nadu, there's a very interesting term they use for stainless steel, very proudly, called ever silver. So they love their stainless steel. They are proud of it. And I spent 4 or 5 hours as an older person shopping here. So stainless steel had this connect with the common Indian person for many years, but only in this form. Only and only in this form. So I would like to tie back to ISSDA now, because I have a connect with ISSDA. I've seen it at close quarters. In 1989 is when ISSDA was formed. I'd like to touch upon 2 things here. ISSDA for me is what architectural community has never been, which is collaborative. I think all of you would agree. We don't share knowledge. We don't like to collaborate with other architects. We don't like to share a good experience, a good vendor, a good contractor. There is something about us architects that makes us insecure, right? ISSDA managed to fight this insecurity amongst steel giants of India, bring them together, and make them see that if they collaborate, they all grow, which the architectural community still doesn't understand, unfortunately. And I'm talking about my generation. I'm sure it was there in earlier generations. So ISSDA for me is a body that has taught the industry, steel industry, a thing which is very precious, is that collaboration means growth. And I'm hoping you youngsters understand this. Do you all listen to a lot of music, I'm sure? Yeah, from all over the world, yes? You also understand that rock bands today, musical bands today, don't have fixed members, yes? They're all freelancing, am I right? You'll suddenly see a guitarist playing in one band and then in another. Collaboration. You'll see 7 musicians from different countries coming together. Collaboration. And I think the music scene has never been better than this. And even the Indian music scene, right? So collaboration. ISSDA came in 1989. Coming back to the talk, This was the time India only knew stainless steel as vessels. And I'm talking about architects as well. I joined Architecture College in 1989. And the only thing I knew stainless steel for is vessels. It was a very sad commentary because you must see this now. 1989 was the time, 60 years before that, the world was doing this. Europe, America, Australia, much younger countries than us, some of them, most of them actually, were doing this with stainless steel already. So the Chrysler building mentioned often in all the talks was built in 1929, 1930. Can you imagine the kind of this thing? And stainless steel was used in the crown of the building, and they called for 10% extra material, and that 10% extra material is still lying there because they never needed it, right? So the architects and designers in the West and in Europe used this material very effectively so many years back. They also explored the various forms. So stainless steel is not just about a single narrative. It is about many ways in which it can exist. It can exist as sheets, it can exist as corrugated sheets, extrusions, solid sections. So it's an absolutely magical material for designers. The expressions abroad say 1993, this building, all of you recognize it, I know, because it's quite a famous building. Architecture usage became dramatic because they said, gosh, we can do pretty much anything in this material. You can curve it, you can bend it, you can fold it, you can shape it, you can cast it, you can pretty much do anything. So usages became quite dramatic, quite well seen in all the buildings. Also status symbols. So the Canberra building, which is on the bottom right for you, the architect was given the brief, use a material for the roof flagpole, which lasts 200 years. 200 years, and the obvious choice was stainless steel. So stainless steel has fast become, over the years, a status symbol as well, something which talks of progress. And these amazing qualities. The reflective stainless steel, which can very well be used outdoors. Can you imagine using any material which is reflective outdoors? Even in India? No, it's the only material. And what it does is amazing, yeah? It's like, now you see me, now you don't. It just disappears, it reflects. So some very interesting entries we had for the design understood this and used this quality of reflecting the surrounding. No other material can do this. I'm really sorry, I'm bad at handling this. Now this, I will not dwell too much on this particular slide. You all understand this. A lot of people have explained it much better than I can, which is why stainless steel is very apt for this conference. Why this marriage of ISSDA and USAP is for me an absolute winner, because circular economy is something that fits in completely with stainless steel, completely recyclable, right? Again, for architects, available in all these forms. So there is no limit, there is no, nothing that you can't do in stainless steel. You can pretty much imagine anything, it will get done. So if we understand stainless steel like a performer, you know, if stainless steel were a performer on stage, you have the front stage and you have the backstage, and all of you must have performed sometime or the other. Backstage is as important, not seen much, but as important as the front stage. So it's very important to understand both ends of applications of stainless steel. Sir just told us about a very important application in medical buildings, which many times we don't see like Frank Gehry's building, but it is an absolute backbone of design. And we cannot ignore the backstage performance of stainless steel, and versus Frank Gehry on the front stage, where you're out there. So considering stainless steel as a performer. And that's what I mean by that. Today, just the other day, yesterday, I was seeing that stainless steel reinforcement bars is becoming a very popular thing. High time, high time. We are all suffering with the lack of performance of reinforcement bars in the regular materials. So what is not seen in the use of stainless steel is as important. And remember one thing, all of you, who is giving the specifications? You guys are giving them. Architects are giving the specifications. Unless we understand and realize the importance of this material, we will not be able to take it forward. On the right are the front stage performers, cladding, exterior, glazings, and all kinds of exterior applications. Now I'll touch upon this and then come back to it in the last slide. This is a question you will wonder, like I told you earlier, how will we marry the two? I'm talking about first critical regionalism, contextual design, working with materials which are Indian, which are born from the earth, which are available locally, and then I'm talking about stainless steel. So hold this thought because this is where we all come in as designers. Again, benefits of stainless steel. This slide I've included only for one reason. We all know these benefits. We all know about how it has a long life cycle. How do we convince the client to spend that extra money? For that reason, we need to know very well how this slide goes. We need to have this knowledge, and I request ISSDA to keep engaging with architects, because unless you engage with architects, who will give the specifications? Who will decide to use this material, right? So we have to have a very good knowledge of our materials to be able to sell it to our clients. And we experience this directly while doing a lot of our projects, because you have to really hard sell a new idea to a client and make them understand what life cycle costing is. So when we graduated from college, this is the first opportunity we got to work on the Jindal Stainless office in their mother factory in Hisar. And it was just, I tell you, a golden opportunity for us. We were fresh out of college, a lot of silly, crazy thoughts about the profession and a lot of romantic ideas about how we would design. And we were handed over this project, a small little office space, and told that stainless steel use karna hai. That was our brief. So you can imagine the excitement, the fun we had, and we explored every form of this material in this little space. So whether it's in the ceiling or it's structurally in the porch, that's a proper structural porch that is there. We designed this with the engineers, with the fabricators, or it's the solid sections which were used in the railing, or the cladding, or this little swing element that we created as a seat. Nobody sat on it, that's a different matter, but we did it, and we were so lucky to get complete free hand using tensile properties of this material to create a seat that is suspended, and modularity of this material to be a constraint or a boon. And metal stayed with us right through our design career thereafter, thanks to this project. And at that time, there was a big challenge because there was no fabricators. So we had to call in somebody from South. And this is just a recent photograph. We are still dabbling with the material, enjoying it. We've created a hyperbolic paraboloid shaped railing for a mall. We had to hard sell it to the client and convince him to use stainless steel. These are the mock-up models, 1:5 scale, to understand how it will actually be done with the fabricator. So stainless steel is something that you all have to understand as a material. Now I'd like to touch upon a couple of slides circling back to your core topic of sustainable design. I came across a very interesting article about the city of Venice. Many of us would know that the city of Venice is crumbling, and it's obvious why, because it's in contact with water. It is suffering a lot of abuse over the years because of being in contact there. Stainless steel has played a pivotal role in restoring very subtly all the structures, the bridges there. This is stainless steel as a performer backstage. You can't see it, but it is providing long life and strength to old structures in Venice. And they had entire engineering team doing this, trying to restore without feeling the presence of stainless steel. If you take a look at this, you'll get to know what I'm saying, where certain things were dismantled, stainless steel inserted, and then covered back on to make it look just like it was. because finally that's what we'd like to see, right? So very subtle, gentle, but very important role to play in restoration. And this, like I said, brings us round full circle. Statue of Liberty, an iconic building. Again, once again, a lot of you would know this. It's obviously has a life, much less age than, say, Venice or any monuments in India. But they have restored this, again, very subtly, using stainless steel. And here is where I see an opportunity. I urge the industry, ISSDA, whoever can, to introduce this material in this invisible form for restoration of our monuments. Many of them need help. Many of them need intervention. Can it be done using this material, which will enhance their life manyfold, not just little bit? A lot of buildings are falling, crumbling. They can be helped with very, very intelligent design. Again, to close, coming close to the end of my presentation, adaptive reuse. We see, so I used to go for a meeting to Connaught Place for the last 10, 11 years. I've been going to the same area. And every time I'd go, this is actually a photograph on the left taken from my cell phone. And I was like, what is this building? This has been lying like this, unchanged, for the past 12 years and maybe much, much more. This is the story of a lot of buildings in our city. Why are we building and spreading and occupying ground when we can actually look at this as an option? Why are we not looking at adaptive reuse of underutilized buildings? This is another area of interest for me, and I'm sure it will be for a lot of people, on actually exploring, taking a map and exploring a large part of Connaught Place. Please notice it next time you drive there. I hope you do. So many buildings are underutilized or need help, can be converted into these amazing projects. Can you imagine an architect getting a project like this, and how you can convert it? Adaptive reuse is a very big subject, which I feel should be addressed.
Excuse me.
Now, these are my last few slides, and this is a real request to the students and to people who are having the authority to make these changes. I went for a jury at my old campus at Ahmedabad, CEPT, and juries were going on, and I entered, and the Masters of Architecture program children were making these models there. And I felt like I had become Alice in Wonderland, and because the models were quite large, and I felt like walking through a city of these amazingly designed buildings. The project given to them was also very interesting, of using hydroponic agriculture and making multi-storied buildings to propagate that. But apart from that, what I noticed was the way they had designed their facades. So if you can see these few views, they understood the need to shade, they understood orientation, they designed fins, they designed jalis, all of them interestingly in monochrome. Can you see that only one material was used for their models for a good reason? I'm sure their professors had a good reason. Can we not, all of us, understand the power that we have today? So if a young mind can think of this, if young minds, this is one of the entries of the competition this time, if young minds can think of this, why are we building like this? Why are we building like this? There is a deep questioning required, and at least, so our generation missed the boat. We were a confused lot. But at least this generation should get a voice and demand a voice, I would say, and make sure that your ideas are pushed through in a lot of ways. Ending materiality as an idea, as a concept. Coming back, as I said I would, how earth materials combine with this cold manufactured material. Once again, design mind should never feel that they can't do this or can't do that. Yesterday's presentation of Mr. Charanjit Singh was so inspiring for me, that at this age, after working for so many years, he still feels like this, that why should anything stop us? So when there is a thought, we have tried in all our practice to break the boundaries, move out of comfort zones. So we've intensely detailed elements of design, combining metal with earth materials. So this jali that you see has been built. It's completely a simple design of metal with brick. And it can be done. It can be done. It's successful. It needs a lot of out-of-box thinking, but you can do it. Arches in brick. Jack arches are something that we always are familiar with. Corbusier did a great job of jack arches in India. But we decided to replace the concrete with metal. So there are metal beams and jack arches. So these are ways in which you can easily, and this is what it looks like at the end of the day. Yeah. And let's learn to command the respect of the community at large by respect through innovation, right? That's what I'd like to say. Thank you.
Thank you for your very appreciative presentation regarding culture, material culture and its environment. Thank you. Now I would request Mr. Kunal Mathur. He is a practicing architect since 36 years. He has unfortunately graduated from CEPT Ahmedabad and is a founder cum senior partner in architect Yatindra Mathur. He considers himself lucky to have a lineage of his father, who was an eminent architect in Le Corbusier's team at Chandigarh. He has great exposure and has contributed to many architectural works of various scales and projects in India and abroad. He's contributed to the online sanction procedure in India and was editor-in-chief for 12 years in India Today Group for Building Directory. He's an activist on policy issues and has a passion for capacity building. Thank you.
Thank you, Madam, for inviting me on this dais and presenting my viewpoint on stainless steel, even in front of many of my guru brothers here. We had the same guru, like Mr. Sood and I, we studied in the same building in Ahmedabad, CEPT, and so did Anjali. And I have a lot of excitement to state about the very product stainless steel. It's really amazing to see when you sit, let's say, next to a pond, and you see the water absolutely still, and suddenly you just throw a small piece of stone and it creates ripples. It brings in a different environment. And how it does that always rings a bell into my mind. I find buildings that are mostly static. You see them in the day, well, and you see them after years, probably with some deterioration. And now it's a little bit of change is there because you got these lighting engineers who do a good job of illuminating buildings at night with fancy colors. All the 3 Indian colors are on the buildings these days. Good, bad, or ugly is not my point. My point is that we are looking out for something which is more dynamic in terms of the facades. And to my mind, stainless steel gives us the option of the usage of stainless steel on building facades that will bring in that kind of an excitement. It's amazing to see, big convex mirrors at Jaipur museums.
and concave mirrors at the Jaipur Museum. It's very exciting because they distort your view, they make you look really nice and fat, and they make you look very thin too. At the same time, when I look at materials that are having number of facets in it, it kind of distorts the image of a rod in that place. So the experimentation starts and you build more artistry in your work once you use a product which is stainless steel, having the element that it is very nice, polished, and it is very reflective. So in my presentation, which I'm supposed to have only 20 minutes, and I'll try to put you across to these kind of facades which have always fascinated me in Austria and in Iraq and also in Germany. India also has done a couple of works, and I'm not going to talk about small measures in stainless steel, but I'm going to run you around with something which is more of facades and in public art. So over to my presentation here. This is one of the very interesting buildings. This is for a thermal power station. What I really liked about this facade was that it is made in small steel plates put together. And the beauty is that it shows you the seasons. You connect with the seasons. You connect with the energy over here that this is a thermal steel plant building. And you see at the base, it just gives you a very good glow. Now this kind of a thing changes right from morning till evening. So if you're at that place, the building is reflective of the season. It is reflective even of the time of the day. Early in the morning is different. At night it is different. I love it. It's just like my baldness over here, which shines. Next is this one. This is in UK. They made a nice box. हमारी भी बड़ी सारी buildings बनती हैं छज्जों वाली, सीधी डब्बे डब्बे बनते हैं. Just see how beautifully they've done it here. You see, they're just small panels and they're very highly reflective. And because of the shade and because of the reflection and the facades over here, it gives you a very good effect. All said and done, stainless steel as a material has great amount of, no maintainability is required. It shines the moment it pours, it gets cleaned. It does not catch dust. So all these qualities are probably already discussed in this seminar. So I won't go through that, but what I really like is that as an architect, it's high time we start adopting certain things that are very, very unique and which can bring in certain character and which can, draw people's attention and interest. So this is one of the very interesting buildings, which is just a substation. And how beautifully it is done. Next, please. How things have become very poetic. Here, there is a stainless steel column, and there was cladding, GRC cladding on this building continue with the false ceiling. But these two columns come and hold this building here, and the reflection itself makes poetry out of it. You see, that color is reflected on this shining surface. Not only that, the sky comes and touches here. It brings it down. Now, just imagine when you're drawing and you're making a drawing, how penetrative your idea can be in terms of understanding what colors your building is going to bring about, what season it is going to talk about, what kind of a aroma it will have, and what kind of a music it will produce. So this kind of an element is very important in terms of your whole excitement about the very field of architecture. Something which is very modernistic, you may call it modernistic, but today, because of the high grade of polishes that are available and the good quality of stainless steel that is available, all these possibilities are there. And unless and until we keep experimenting with things, we'll never come out with a great situation. Next. So here in Austria, this is another very interesting element. They've used stainless steel, strips to make this building over here. And this is probably a spring season. So from very far trees, they are all reflecting the colors out here. Every season or every moment looks different on the facade. So it brings in a lot of excitement. You get yourself photographed here, and you can take 10 photographs, maybe perhaps in an hour's time, with a different background and with a different tilt of your camera. You'll see a different color. So there is what is known as a taffeta finish. It's like a taffeta. It's reflecting so many colors on it all the time that you can't, you have to take an imagination of a pure, drawing of a building on your computer terminal, because it'll never give you that effect. You have to be beyond architecture and beyond poetry to understand this material and come out with a very interesting solution. Next. Here, I'm talking about curved surfaces. See the blaze over here and the sky and the mixture of colors that it brings about. It's totally different from what you can do. I know as a child when Chandigarh was being built, we had Corbusier there. I've seen him. He used to come with a small beedi in his mouth and sit on the site and draw the mountains, and then he saw these big cows with the big horns over there, and that's what got him into the angle of design over there. But his material was a pourable concrete. So he experimented a lot on that, and he introduced a lot of colors in the buildings in order to make it different. But not only different, from the utility point of view also, they are great buildings. So I think my country has brilliant architects and brilliant people with great minds. And great minds need a lateral thinking. And in order to achieve that lateral thinking, here this material has immense possibilities. Apart from this, there are a lot of thoughts that come into my mind, is the longevity of the material and longevity of the surface. Which product can give that kind of a longevity? You see, in one of the forums, the question was कि building की life क्या होती है? Assessment of the life of the building for valuation purpose. I just failed to understand what is the life of a building, because the parameters are so complex you make a strong building totally in RCC, and you have a GI pipe going inside, which they say lasts for 25 years. And that GI pipe destroys your building. At the same time, if you have pipes now out of stainless steel, they're not costly. I thought they were very costly pipes. But I recently did one project and I used complete stainless steel pipes over there. The stainless steel piping system had to be very carefully detailed out and worked out because they were expensive pipe. But effectively, the material that we have used is a very small quantity of stainless steel because it can take tremendous amount of pressure. You see, the wall thickness has reduced. The use of that material the consumption of the material has come down substantially. Had we used a material which is steel, the thickness of my pipeline would have been more. But stainless steel thickness reduces a lot. Next, please. Now, this is another building, and here I am able to see it from a flyover. This is in London. This is a music school, and this is the top of the building. They have fully made it with turning the facades up, and it's really great to view this building from the flyover all the time because it looks very interesting. Next, please. And the detailing is like this. See now, that particular strip, it's so pure, poetic, that all of a sudden you find that strip going there and it's having a different color. It's kind of shining, and all the other shades, all the other facades are bluish and getting into dark blue colors. How can we achieve that with any other material? I don't see the possibility. Next. Then here again, this photograph, niche wala, here it is glass, and here it was stainless steel, which is corrugated stainless steel. But the reflection into the glass makes it look as if the facade is carried through and through down into the glass. So beyond architecture, there is a measurable thing and an immeasurable aspect. And I think the imagination goes way beyond here into the unimaginable aspects of the treatment that can be brought out by use of this material, which is highly reflective. Next. In Chicago, this is a very famous, the bean it is called, and it is 30 meter by 20 meter by 13 meters high. They have used 98 tons of stainless steel to make it, and used some of the best consultants, and number of the best consultants in the world even told that this is not possible to make it. Now just imagine what all it does. This is Chicago skyline reflected over here, and that's the sky on top. You can walk underneath this place and go all around. But at the same time, they have a very good budget for maintaining it. They have, throughout the day, they are able to clean up till 6 meters of its height. Throughout the day, there is cleaning with a polishing machine, and twice in a year, they clean it with Tide. Surf jo hota hai, that sort of a thing. But this material keeps shining, and it is made with about 112 pieces put together, and it is totally seamless welding overdone here. Keyhole, welding was done. So keyhole means that all the seams were first made, which are reverse seams, which are not seen on the surface, and through a keyhole, they welded from inside. And structurally also, it has 2 rings inside. Well, the person who designed it is from from Indian origin. He's from Doon School. And Anish Kapoor. And when Anish designed it, he needed support and a lot of collaboration from Overroop and Company in London, who refused it. They said that no, this is just not possible. There were various experts who said that the expansion and contraction is a killer over here, and those challenges cannot be met. So you see, there is an idea, and behind that idea, then everything else falls in place. You need great engineering, you need great understanding of its maintenance. Some people said that it will become so hot that if you touch it, your fingers will burn. Others pointed out that, you know, in Chicago, it's so cold that if you go near it, your nose will freeze. Now, there were so many apprehensions, but at the same time, it faces all these vagaries of weather in Chicago, and it's a beautiful piece of art. People go from all over the world to get to this particular monument, and they enjoy the garden next to it. It's a very exciting place. So your contribution to architecture is always a dent and a very important aspect is that what is architecture? According to me, it is next to godliness, because God has created the earth, and in that you are doing an implant. And in order to do that implant, you need to do it with some force and with great understanding of how you will make it more and more exciting and more valuable. Anish Kapoor, who designed this, had a contract that this particular monument should last for 1,000 years. He had to give a written guarantee. I don't know whether he did it because he knew he would never live to it, but he signed that contract. And mind you, it's an American contract, and Americans are very strong in their contracts. They'll bring every rupee back or every dollar back from his family and from all his assets in case it fails. So he had the conviction that using this material will last for 1,000 years. So when I referred earlier that buildings and the life of the building, we are only able to think about 50 years and 100 years here in India. My point is, can we think of anything which we can commit for 500 years with good performance, of course, with little bit of maintenance, no doubt. But that's the quality of this material. I wanted to bring it forward in this forum. Now, this is a very fascinating one. And you see that eye over there, that big ball? This is what you see at night. And after seeing this, every time I'm driving my car, and I see on the rear view mirror, you know, there is another enlargement over there of what's coming from behind. It looks like that, you know, concave mirror. But it gives me a very great thriller of all the monuments that are nearby, how they are reflecting in this stainless steel monument which has been created in this plaza over here. Next, please. Next. This is in Israel. In Israel, they had, this is called upside world, but it's a very simple structure. But very interesting. You connect with it so well. You go near it, and you find your image almost upside down, and you see the shape, which is so plastic in its look and so reflective. It's very exciting to see it. Now, this is a very good example done recently in Surat. This is a very big ball, a drop, as they call it. And this is at the Surat Diamond Merchants Association building. So done by, in India. Here he has used number of facets put together, which are actually straight pieces of stainless steel. And all the interior over here, you see the floor part reflects somewhere, and the ceiling reflection is somewhere else on this. So all the time when you go around, it's quite exciting and quite an eye catcher. So this is what I felt, that projects which we are going to come up in the future needs to be looked differently, and we need to take up the challenge of using and experimenting with something which will make, unmeasurable aspects in architecture. Thank you very much.
Thank you for your very interesting presentation, highlighting the innovative use of stainless steel material. Now I would open the house for questions, if any.
Good afternoon, everyone. I'm Sneha Sharma, a fourth-year student from USAP. My question is to Kunal, sir. Sir, you've shown us really magnificent uses of stainless steel in facades, but for us, as we've been learning about sustainability and how, if we talk about steel in facade, there is also a very high reflective heat reflectance that is present. Other than that, what would the surface temperature of that facade be? And also, if we start using steel as a facade element, do we not lose a certain amount of cultural identity of the space?
Well, I have a small story to tell you. When we talk about cultural identity, I go back to my hometown, Chandigarh. There was this debate all the time where the capital of Chandigarh should be. So they said, Amritsar में ना model town है, उसको बढ़ा देते हैं उसके आसपास. So we'll have a capital over there. Then they thought that no, this is not the right place. Let's go to this city and let's start having some organic attachment to it and make another capital. But it was great minds put together. They said, no, let's start afresh because we need to have new India and new thoughts. And we need to have an environment that is totally different. So they selected a place totally different. It didn't have any cultural roots over there. They just had this big agricultural land which was acquired on the basis that, yes, building material is easily available. There is ghaggar, जहाँ से sand मिल जाएगा, pebbles मिल जाएंगे for good concreting. And they got great minds and a totally different mindset to set up that city. And mind you, that city is considered one of the best designed cities in the world. So what are we going to look at culture? Some of the culture may be ruinous to us. How do you want to keep associating with it? And how much knowledge do we have of that culture? It's very nice to keep remembering your culture, being proud of it. But the whole aspect is that what can we pick up which is really enriching us, and we can project that in our culture or in our buildings. Do we back cycle the circle of time, or can we bring in some creativity somewhere? Great artists have worked, and a lot of people have again, made a sketch or made a painting of Mona Lisa. But Mona Lisa is original. There's only one painting which is protected in a museum, which is ruined in a museum, which is plundered in a museum for various ways. But there is only one Mona Lisa. What's great about it? Because it is Mona Lisa. And technical aspects, yes, one can always look into it. What kind of a heat radiance it will give, what are the factors to it. They are all part of your understanding of what you want to create. After all, this bean was made. The temperatures over there, minus 15 degrees Celsius and all that, and snow falling on top of it. So it is still there, no? It's still nice and shining. It has been taken care of. People go there. I went there and I touched the bean over there. My finger did not freeze, probably because my blood was very excited. That's it.
So any other question to any other panelist?
Sir, I don't have question. Just I wanted to add something to what Dr. Anil, Professor Anil Dewan has said. Sometime around 40 years back or so, we made Operation Theatre wall paneling in Shankar Netralaya in Chennai from Salem Steel Plant. And I think probably it was, if you can correct me, was it the first one in India? It was the first one. Yeah. That's all. Thank you.
We may have one or two questions more. Can we have? Yeah.
Good evening to everyone. So my question is to, I guess, like everyone. So how to use like stainless steel for the like earthquake resistant structures? We are facing all those things in Delhi NCRs or in your earthquake, in Uttarakhand. So how we can actually use those kind of
Well, in Uttarakhand, if you see use of stainless steel, especially in bridges, the first very bridge was a suspension bridge, and that suspension bridge is Lakshman Jhula. Suspension bridges are usually around 25% cheaper than concrete bridges and pre-stressed concrete bridges. So that's one. Then second thing is stainless steel and its use in pre-stressed concrete. You see, we are using PT slabs, pre-stressed concrete slabs. Simply, it's amazing because in pre-stressed concrete slabs, we are having beams and it's a regular, beam structure with columns and all that. So there, stainless steel is very useful because it takes in it has great yield strength. You see, my steel ropes can go up to an yield strength of around 400, that figure, whatever is the, and unit. Otherwise, stainless steel goes easily as high as 1,000. So I use very less material and I use stainless steel there. Now, stainless steel wires are very, very good, in taking a lot of stress. So the yield strength being very good and the consumption of the material being very less, it's very advantageous to use it in structures. Actually, India mein na abhi jo code hai hamara, stainless steel, use of reinforcement in stainless steel, that code needs great amount of revision. It's outdated. It's just a copy of what steel code is there and the Indian code. So we don't get any advantage. So stainless steel will never come up unless there is a great structural engineer or a body of structural engineers who can reframe the code. Once we reframe the code, then it will become economical and very purposeful to use it in buildings, in ordinary buildings and in regular buildings, you know, and its usage will go up tremendously. But India mein code hi nahi hai wo. Like, we are all grateful that we have the Council of Architecture in India, and we are registered architects, and we bar foreign architects to practice in India. But there is no engineering body in India or a council of engineers in India. It's ridiculous. Itne saal ho gaye azadi ke, par parliament mein nobody has been able to push that, you know, the bill through for engineers. So unless and until we all work on it and bring it to a national level and we get it through the parliament, then only things will work out. Thank you.
Thank you, Architect Kunal Mathurji. I think now, if there are some more questions, we can take them during our networking tea session after the final session of this particular day. So on behalf of the organizing committee, I would like to thank all our incredible speakers on the dais for their thoughtful and insightful presentations. And of course, thank you all again for your attention and participation. Now we would like to take a moment to express our gratitude to our esteemed speakers. So I would like to request Professor Dr. Nirja Ma'am, Dean USAP, and Mr. Rajamani Krishnamurthy, President ISSDA, to kindly felicitate our speakers. Ma'am and sir, please. I would also request Mrs. Mathur to come on the dais for the felicitations of our speakers. Thank you, ma'am. So nice. Now, I'll request Madam Mathur. Yeah, I just announced this.
Madam Mathur will felicitate all our moderators and distinguished speakers today. Thank you.
So, I request Mr. Sood kindly moderator for the session. Thank you, sir. Now I request Professor Dr. Anil Devan, sir, to kindly come forward. Thank you, sir. Now I request Mr. Mathur, sir, to kindly come forward for the Thank you, sir. Now I request architect Anjali Shukla to kindly come forward.
Your own daughter, ma'am.
That's great, thank you. So thank you so much for being here. Thank you, ma'am. Now we shall move forward with our next round of panel discussion. I request Shweta ma'am to kindly.
Good afternoon, everyone. This is Dr. Charu Nangia, Associate Professor, University School of Architecture and Planning. I welcome everyone to this last session of this insightful conference. This session is Conference Roundup. To conduct this session, I would like to invite Dr. Shweta Manchanda ma'am as moderator of this session to the stage. We welcome you, ma'am. Dr. Shweta Manchanda is professor at USAP on deputation from SPA, New Delhi, where she has been served for the last 10 years. She is an architect and environmental designer and has received her bachelor's degree from School of Planning and Architecture, New Delhi, master's and doctorate degree from University of Cambridge, UK. She has been involved with practice and teaching both in India and abroad. She has worked with Manchanda Associates Delhi and with SOM Chicago, and has taught at the University of Michigan and Rick School of Built Environment, Noida. Her project involvements include the sustainability strategy for Mumbai Airport, JP Sports City. Her research work has focused energy efficiency and shading system devices. She is on the advisory committee of the Bureau of Energy Efficiency and MNRE India. We welcome you, ma'am, as moderator of this session. Now, I would like to invite the panelist of the session, architect Rajesh Luthra. He is from Development Consortium. Architect Avtar Singh, senior faculty member, USAP. Mr. Rohit Kumar, ISSDA. Architect Sachin Rastogi, Z-Lab. Mr. Neeraj Kapoor, Director, SETI, New Delhi office. Now I request Dr. Shweta Manchanda, the moderator of the session, to take over the stage and start the session. Ma'am, please.
Thank you so much, Dr. Charu. And thank you for introducing me. I would like to introduce all the panelists that we have today. First of all, I'd like to introduce architect Rajesh Luthra. Rajesh Luthra is an architect in professional practice in Delhi for over 2 decades, with works largely in North India. He completed his graduation from the School of Planning and Architecture and his postgraduate studies from Columbia University in New York, USA. Development Consortium, the consultancy he has founded, has serviced numerous corporates, public sector units, and developers, including the Delhi Metro Rail Corporation, with which there has been an association of almost 2 decades. He has also been associated with varied academic institutions and has publications in several journals to his credit. Thank you for being here, Rajesh. Next, I would like to introduce our co-faculty member, Professor Avtar Singh. Professor Avtar Singh did his graduation from the Chandigarh College of Architecture, CCA. He did his post-graduation in acoustics from Jamia Millia Islamia University, New Delhi. He is an architect and academician, presently working as an associate professor at the University School of Architecture and Planning, GGS-IPU. He has worked with reputed Indian architects and has designed various institutional, residential, and university building projects in India. He has also worked on various international airport designs in India and abroad with International Airports Authority and the Airport Authority of India, now Airport Authority of India. Sorry. Thank you, sir. I now introduce Neeraj Kapoor. Neeraj is trained as an architect and I believe he's graduated from the TVB School of Habitat Studies. He is also a self-taught engineer. He is the Director of Operations for the New Delhi office of the SETI Group. This is a company that works in the core areas of 4Ds, MEP design engineering, decarbonization, digital twins, and as a project developer's rep, Neeraj has been at the forefront working for the last 20 years in the area of sustainability, energy efficiency, and building automation. Thank you for being here, Neeraj. I would like to introduce architect Sachin Rastogi. Architect Sachin Rastogi is a graduate of the School of Planning and Architecture, New Delhi, and he has done his postgraduate studies from the Architectural Association, London. He works in the area of sustainability and sustainable architectural design, one of the few architects combining the two fields very effectively. Some of his notable projects include the Zero Energy Group Housing for the ACC Group in Bellary, Sustainability Master Plans for the Lord Stadium, London, Master Plan for Prague Riverside City Centre, and Jumeirah Beach Development. Thank you for coming here, Sachin. And last but not the least, I would like to introduce Mr. Rohit Kumar again. He's Executive Director, ISSDA, and he has been instrumental for bringing us all together over here. Mr. Rohit Kumar brings with him a wealth of experience in various aspects of the stainless steel industry, as we have already seen from his presentations. He is a postgraduate in metallurgy from IIT Kanpur, and prior to joining ISSDA, he has been associated with Jindal Stainless in their research and development department. He has also gained experience in product development of long products while working with Sunflag Iron and Steel. Thank you, Rohit. So thank you, everyone, for staying here till this roundup session. I hope that by bringing these panelists together, we can gather our thoughts from our learnings over the 2 days. When we decided to do this conference, we thought that we will bring in something new for ISSDA, with the expertise that we have as academics. And as we have seen over the last 2 days, yesterday we had sessions which were focusing on infrastructure and transit buildings. And today we have had sessions on, architectural innovations and new applications. And so we can see that there are certain fields where stainless steel is perhaps now in India a little bit fairly established. And I think from today's, particularly today's discussions, has really opened up our minds to how this material can really be explored in so many different directions. So I think this, probably ISSDA will appreciate this new angle that has been thrown open by our discussions today. And I would like to add that, as architects, we are a unique profession that brings art and science together. So this is, when I was introduced to architecture, this is the way I was introduced, that it brings the fields of art and science together. And I think this is extremely key for, for the public understanding. And it brings to mind, something that I came across in a film which said that, while science and logic is very essential to our growth and, it's for our intellect and it is considered very intellectual, we actually live for poetry, for art. So this is what really kind of instills feeling in our soul. So if we don't have art and poetry in whatever we do, we are not really living. So I think with that, I would initiate, with that thought in my mind, I would like to initiate the first question, and also inspired by the presentations today. While I think, as a sustainability proponent, I do endorse embodied energy and the learnings of the vernacular. And as Ms. Shukla has also pointed out, vernacular is something that we should endorse. I think the glamour that this material brings with, its shine and its quality and its smoothness is undeniable. And, when we look at buildings of Frank Gehry, the Chrysler building or the Bean, I think we are all, we all want to go and visit those buildings and, they get etched in our memory. So my first question is for architect Rajesh Luthra, and I would like to ask him that, with this context, maybe cost could be one factor, but besides that, what do you think is preventing the Indian market from moving forward and taking this material up in a big way to enhance our urban scape?
Thank you very much, first of all, for this opportunity to be here and to share my thoughts. Hello, yeah. So I'm just going to repeat everything I said. Thank you very much for this opportunity to be here and to share my thoughts, and also to educate, this opportunity to educate myself and take my understanding of stainless steel a lot further. So to come to what you have inquired of is, as a practicing architect, as a professional architect, comes to mind when we do our material selection, like you said, was cost. You spoke about that. There's opportunity, and then there's vision. This vision has to be built on information. And I think there's a paucity, there's a very definite paucity of information, I would say. It's almost like there are habitual responses to material, there are ingrained, inherited responses to material. Stainless steel does not fall in any of these categories. One of the last building which Le Corbusier designed before he died was built in steel, in mild steel. Had Le Corbusier done even one building in Chandigarh in steel, Chandigarh being a laboratory for architects of that generation, which sort of took the discussion further for decades at end. It still is on, that discussion still is very much on. You would have found steel to be a point of experimentation. You would have found it to be an idiom which would have got ingrained in the Indian psyche like concrete has. I mean, we think of Chandigarh as an Indian city now. We do not speak about it as a Swiss-French architect's vision, which was superimposed on us, so to say. So information, to my mind, is something which is very important. Let's look at how stainless steel is used. We talk about stainless steel, and what comes to mind in the contemporary idiom are buildings of Frank Gehry or other Western architects, where they could have as easily used copper cladding or something, or what we call aluco bond aluminum cladding, right? Stainless steel lends it that extra sheen, that extra richness, but are we doing justice to the material, so to say? The fact that stainless steel structurally would be X times superior to mild steel, right? So there is that aspect of usage. Now, what in my practice and what I've seen with my clients stops the client from using stainless steel instead of mild steel in reinforcement is the cost factor. It can't be justified unless, of course, the calculations are done in a manner where you say, I'll save so much on that. So it does come back to it starts with the cost effectiveness. If one only talks about an ornamental response, then it's not going to go very much further. It's not going to justify, for instance, the immense intellectual repository that this conference, this 2 days of meeting of minds has been. So it has to start with that justification, and then it has to be information which has to be disseminated very effectively.
Okay, thank you so much. I think there are a couple of points which I think kind of resonate with me. I think one is the habitual kind of response, and I think maybe there was somebody who mentioned that, if there's no concrete, then there's no building. I mean, I think something to that effect, maybe not exactly, but I think that is the public understanding that a building is made from bricks and concrete, and there are no other options. So that is one thing. And the other thing, what you said is that SS is definitely much more than just a surface treatment. So it has such great qualities besides its luster that unless we kind of cash in on those qualities, it can't be really appreciated to its full potential. So with that, I come to my next question, which I pose to...
I'll just add one point, with your permission. One of the speakers had spoken about this building in New York, the Chrysler building, which was built in 1930, had spoken about how the Chrysler building has its top in the imitation of the front fender of a Chrysler car. And the top of the building is clad in stainless steel, which... So what was not mentioned at that point in time is that during the last almost 100 years since it was built, it has been cleaned only 4 times. It has needed to be cleaned only 4 times. Now you compare that to another surface, which requires maintenance possibly every 5 years or 10 years. You see aluminum cladding in the malls in Delhi, and you see what happens if they're not maintained. So that was something which I was reminded of when that...
Yeah, absolutely. So that is what I'm coming to next, is this point of circular economy. And I pose this point to... Yeah, no, it's working. Yeah, architect Avtar Singh, that, I think this conference, by theming it on sustainable architecture and the circular economy, this really drives down this point that if we are able to use this material in multiple ways, say for example, maybe replacing a roof structure in maybe a shelled roof, or replacing a structural element, or maybe even the kind of the invisible costs of public health. Because we have to recognize that if people get sick, it is actually a cost to the nation and to corporates and to firms. Do you think that by addressing these issues, we can use, if we recognize the role of the material in the circular economy, then its value can really be appreciated?
Thank you, ma'am. I think this was a wonderful 2 days of what we had here. It was a great learning for me, and I had very little knowledge about stainless steel. Knew about it as, like somebody said, the utensils and things like that. But knowing it as a material has been an eye-opener in this conference. And I think the best part here is that, to understand the properties of the materials and put it across in the places where it can be used to the effective manner. So that, one of the things which I think was understated in many ways, it has been mentioned, except that in the hospitals it is used as a kind of a material for its cleanability and its hygienic qualities. But I think it's also a very, very important to look into this material as a material for public health in general. Because in places, we go around, and the most important contact we make with the hand and the mouth, and we touch surfaces, and there are these surfaces which are lined all over, especially in the areas where, the mass movement of people happens, and there are a lot of people touching different surfaces. And those surfaces, if they're made in wood, or they're made in concrete, or they're made in brick, or any other material, they will absorb the kind of, viruses and infections, which are very, very common in certain seasons of the year. So if using this quality of the stainless steel for its cleanability and, its hygienic properties would be very, very important. If we can somehow, use this material, especially its smoothness of the material is so much that its cleanability can be, achieved in with very little effort. And that can be used in the touchdown zones of the people where they're moving. I'm saying from the knee height to the, almost the human height. That is the area which are surfaces which are being touched. Normally the counters in the banks, or the ticket counters, or pharmacy counters, where we go around all these places, and the surfaces. Railings are one thing which has been, very, very good in they have been used in stainless steel, is now being very popular there. But I would say that the surfaces lining in all these areas, other than the hospitals, will also increase the hygienic potential of the places, and reduce the spread of infections and diseases, and would make probably the public health would be much more better saved if we start using these materials in the areas which the public is really in the movement and continuously in the movement. That could be one of the things where this material has a potential, rather than simply saying that it can be used in certain expenses. Definitely one of the things why it's ruled out. But when we talk about the public health, I find that the cleanability of this and the neat lines and the kind of looks it gives is a very, very important aspect of this material, which can make it to be useful in all these public places. And that could be the thing which can be not compromised with the cost only, but we can use it in these areas.
Thank you so much, sir. I think with his, long experience of practice and teaching and his eye for detail, I think we would really find, I would consider this as very sound advice. And I would also like to mention that in my discussions with him when designing the points for this panel, a few other points came up. So whatever I'm going to ask the remaining panelists are, actually based on the discussions that we've had. So with that, I come to our next panelist, Neeraj Kapoor. I think, when we talk about circular economy and sustainability, we cannot deny the role of energy efficiency. So this has become a big buzzword, and there has been immense work that is happening on energy efficiency in buildings. We know that buildings contribute a third of the energy consumptions globally, and so there is a huge impact there. And now the embodied content of materials is also being questioned. So my question to Neeraj is that, of course, every material has, a relative embodied content, and maybe stainless steel is somewhere in the middle of the spectrum. So, but because of its other properties and maybe perhaps new uses for, SS in, I don't know, in building automation, or maybe bimetals or something which is, out of, to be innovated, can we perhaps, look at how this material can enhance energy efficiency in buildings?
Sure. Thank you. Thank you for having me here. Good question. But let me go a step back and try and address some of the root question of this discussion as to why steel has not really caught on in our, larger imagination. And then I'll obviously discuss some of the points that I've noted down here. Glamour, it's undeniable. We have been discussing about this, as you said, steel as by means of looking at it on the facade or on the face of things, more of an aesthetic value, a bold, glamorous look. Other places that we have usually seen is if you see buildings as humans, then think of the bones, the structural, and the integrity of it. So steel has been discussed in that sense as well. So where I come in is more from an inside out of a body, from the nervous system, you can say, or perhaps the systems as the way different body parts come together, whether it is your, not the bones or the musculoskeletal system, or not the skin or your facade, but more of the intelligence and the nervous system. Now, many of the qualities have already been discussed, whether it is reflectance, it is public health use or durability, lack of corrosion, high strength, operational expense, and so on. I think we need to look beyond just the obvious places where steel can be used, but we need to also look at the science of it. And that is where I would want students, I would like to encourage them to look at some of the questions actually that came earlier in the panel earlier was about, why doesn't it get hot? Or those are really valid questions. Or why doesn't it get really cold and freezing cold in the middle of the night? So those are things have to be addressed. What are the big problems that the steel can address, that stainless steel can address, that any other material can't? And the Chrysler building thing that I wanted to bring here, if you start looking at the fact that it was only cleaned 4 times, like Rajesh mentioned, what does it mean in case of Delhi? Doesn't that make it a very valuable, doesn't it solve for the dust? Doesn't it solve for the pollution and, all of that? And then we start changing our self-image about, using steel as being a developing country or a poor country or something that we can't afford and so on. That self-image changes from, we are giving value, and then the question of cost doesn't really. So we are not equating money with as cost. We have to look beyond. We have to look what value as problem solvers, as designers, as engineers can we bring to the table. Coming to the question of energy, yes, embodied energy. But if that building is going to last 1,000 years, it changes the game.
Thank you so much, Neeraj. I think there are such valid points, and again, driving down to that whole idea of circular economy. And I think that I think we are, when we design, we forget the energy that people are putting in. When we account for energy of buildings, even when we are accounting for embodied energy, we should see that when we are putting a building together, there's a lot of energy that is going, that the people who are involved in the design and the construction process, there's human energy that's going in, which is completely not accounted for. And, that kind of brings me to this other point that you made, is about the integrity of the building, or the contribution of stainless steel to the integrity of the building. And tying these 2 points together, I would like to pose my question to our 4th panelist, architect Sachin Rastogi, that in today's day and age, are we looking at static buildings? I mean, do we really want to design buildings that are just static in time? And with that, I'm not only talking about buildings that will react to, the vagaries of the environment, but also, we've seen through COVID times how we need to change our spaces and make adaptive buildings. And with that, something that we are exploring in our studios as well is design for disassembly. So can stainless steel perhaps play a role in design for disassembly, whereby it can, again, feed into this question of circular economy?
Yeah, hi. Thank you for this opportunity, and a great question. In fact, I was just thinking that one of the major advantage of using steel is flexibility. Now, you can see that the kind of material palette we have been working with, whether it is brick, RCC, or anything, it has led to a certain way we design buildings. And the whole industry, the furniture, other materials, interiors, the whole industry then respond to the way architects design those buildings. Now currently, 90 degrees, even in schools, when we go to colleges and we teach students, we say that, okay, you are doing an odd form. How is the furniture going to fit in? How is anything else going to be part of this space? Usage is a big issue. Now the problem is that we have never thought of this flexibility and we have not taught our future architects that flexibility is very, very important. And yes, the industry doesn't support it today, but the industry will transform. And steel is one such material which is going to do it for the whole world. So being it form, flexible spaces which can be deformed and become something else. Now the land is becoming a very, very expensive resource. And you want to build less and use more, to be more flexible, to be able to express the building in various ways. Now you can look at American cities which are using educational building not during the standard time, but they're running all throughout and catering to more number of students as opposed to the Indian education system, which is still running on infrastructure heavy programs. The problem is, again, whenever I pose these questions to the clients, they say that, where is the flexibility to do this? What is the material typology? What is the cost? So once we start knowing, and informing the market that, yes, this is the need of the hour, I think everything about the construction industry can change, and this flexibility criteria is going to be a big eye-opener as we move forward. Thank you.
Thank you, Sachin. And I think what he is really saying that we have to drive the message home. And by having meetings like this is, what we can do. And I also feel that as, academicians and knowledge partners, we can do much more than just, bringing people together. Perhaps we can research on, these new avenues. So I think there's enough food for thought, and I will now open it up to our representative from the steel industry, Mr. Rohit Kumar, what his thoughts are on all the points that our panelists have brought forth this evening.
Thank you, ma'am. First of all, I'm the alone metallurgist sitting among architects. And ma'am, in the beginning you said that architecture is about art and science. So I'll say metallurgy is about science, yes, definitely. And since we are working at atomic level, so it is also about imagination and music to our ears. And music means you have to focus and put some music on, light music. So going ahead with this thought, right from the beginning, all the suggestions and please understand, it was music to my ears because for last 22 years, I have been working with stainless steel industry and trying to promote stainless steel and its uses. In the morning topic where I had a detailed presentation, I tried to put on a lot of aspects of stainless steel products, its properties. It's a wonder material. You just don't see it in terms of one aspect of it, hygiene, or one aspect of it, beautifulness, luster, or the variety of experience it gives in different finishes. But it has such a wonderful mechanical properties. What he's saying, you need to explore, expect the education regarding its weight to strength ratio, regarding its other properties of impact strength, how you can make it thinner and use it and create more space, allow more space to perform for an architect. It is always a dream to have more space to work upon. So these are the wonderful qualities of stainless steel which is there. Now, the lack of information, as I told you, 22 years, I am still working on it. We are second largest consumer of stainless steel in the world, after China perhaps. But in architecture and building and construction, most of these materials are going into handrails, gates, probably some in claddings, mostly in claddings. You see in lift areas, you see it in hotels, you see claddings. Airports, you see a lot of claddings. Metro stations, DMRC has been one of the pioneers in using stainless steel in their station infrastructure. Even manhole covers, their trench covers also are in stainless steel. So it is there in large quantity, but it is at one stage. It has to go beyond that stage as you all are imagining since the last 2 days that facade is one of the things, and facade, when I say facade, it is just not the beautifulness of it, but also the energy saving characteristic of it, how it can be used as a device to save energy for the building, because you rightly said 36% of the energy use is in the building itself, all over world. See, the moment you vision something as an architect, then probably you have taken a lot of aspects of design into it, but then at the end of the day, he is rightly saying that it has to be made possible. And for that you need a good fabricator, for that you need good design codes, which he was mentioning in last session, and for that you also need lot of information coming to you at the right time, at the right pace, with lot of authority. And by then only you will be able to do that design or possibly make it happen. Now I am happy to tell you that the reinforcement bar for stainless steel, which came, the standard came in 2017, but the uses only started after 2019, 2020, and today we are sitting with Indian Railways is using thousands and thousands of tons, NHAI is using thousands and thousands of tons, and yesterday our good friend who made a presentation from Jindal Stainless, he announced that there is a big building coming up now with stainless steel reinforcement bars. He did not want to divulge the details. So we are slowly picking up and trying to spread information. This particular conference is about that only, to understand from all of you where we are lacking, where we want to improve ourselves, and bring forth what is required to see this dream happen. Thank you.
So thank you, Rohit. I think
Yeah, this conference was about circular economy and stainless steel. One of the important aspects of circular economy is that the material should be able to be used again. You know, one of the important thing that will happen only when we can retrieve the material. You know, most of the time at the end of the life of a building, the building we look at and we say that the only thing is the demolition. Now, demolition is a very, very, cruel way of ending a building. You know, you just explode it and then get the material. And the retrieval part will be much, it depends upon what we get out of it. But is it possible that we can do some kind of disassembly of the materials that we have put in the beginning? Can we think of, as architects, about the details which are being put up to manufacture, build the things, and can we simultaneously have the details along with the construction details of how to dismantle it and reuse it? And that will make the buildings as a resource. You know, many buildings have lived their life, but not all the components of the buildings are, useless. So some of the building materials can be retrieved if they can be disassembled in a way that is useful and that can be reused elsewhere. So that could be one of the things which one can really look into, because many times what I've seen is that the buildings are built and I stay in Noida. And there were houses built in 30 years' time. Most of the houses have started now, being dismantled because people want new designs. There are good materials inside those buildings, but they cannot be retrieved. There is stone, there are bricks, there are tiles, there are steel. Everything is mangled, and we get it, in the form which cannot be used except they go into the landfill sites. So is it possible that, we can really work out, while we are working on the details of construction, we work on with the details of deconstruction and then start making the buildings, the materials useful for that in the end? That's all. Thank you.
Yeah.
So those are just wonderful thoughts. Actually, you just echoed what I was wanting to say, that, there's been so much learning from, these different sessions. In fact, with discussions with you, I did not even realize that there was this move away from maybe structural glazing to curtain glass, and we are really not using materials in multiple ways. So I think I would request ISSDA to give this a thought, that perhaps a guidebook could be, you've talked about different grades. We were not even aware of, that steel comes in so many different grades with so many different combinations, and which grade is appropriate for what use. So maybe something which is a user-friendly manual. As you may have realized, that architects kind of speak a different language and understand a sort of slightly different language. So a guidebook that is user-friendly for the individuals who are giving the specifications for buildings may be something invaluable to launch this material in a big way in the building industry.
Ma'am, I think with permission from our President, Mr. Rajamani Krishnamurthy, I would straight away take this opportunity to create such document in collaboration with academics like you and industry like us, with some of the experts in the panel. And we have enough material with us in different forms, but in the eye of an architect, I would like to see from their eye and create that document so that it helps them to realize this dream. So we'll take it forward from here.
Okay, that's wonderful to hear. With that, I will wrap up the session.
So there's just one thing I wanted to say, that we have had overwhelming contribution from DMRC, from Delhi Metro Rail Corporation, in this conference. All the stations, all the metro stations which we have in the NCR are made of concrete, except for one. There's one which is made of steel. How about a stainless steel station? It'll capture the popular imagination, and it might just sort of throw things at a different level.
I definitely look forward to it, sir, because the first coach in stainless steel, austenitic stainless steel, was used by DMRC. There was a lot of debate between aluminium and stainless steel when in 20 years back. Then in stations also, at various places, we had got good technical collaboration, and probably for this also we'll definitely approach forward. Yeah.
Okay, thank you so much to all the panelists. I request
Thank you,
ma'am to close.
thank you, ma'am, and I really thank all the panelist members to share their thoughts and their experiences with us for this insightful section. Now I would like to invite Mr. Rajamani Krishnamurthy, President of ISSDA, Mr. Rohit Kumar, Professor Dr. Nirja Lugani Sethi, and Director and Professor Sani, and Madam Shweta Manchanda to come forward and felicitate our panelists. Architect Rajesh Luthra. Architect Avtar Singh. Mr. Rohit Kumar. Architect Sachin Rastogi. Mr. Neeraj Kapoor. Thank you very much, all the panelists and the presenters. Now, may I request, no, ma'am.
Director sir, please. Director sir, can you just join us on the dais, please? A.K. Saini sir, please. We'll just like to felicitate the students and the faculty member who made the digital presence of the conference important for us. So I'll just like to call Dr. Nanki Nath, faculty USDI, on the stage, just a token of appreciation and a certificate. Yeah. Kashfi Mehta, USDI student. Mr. Tanishq Nirvan, USAR. Kindly join us on the stage, please. Kashfi Mehta. Tanishq Nirvan. Sir. He's not saying anything. दो लाइनों में बोल के दे दो आपको. As we come to the close of this two-day-long conference on sustainability, nation building, and circular economy, I'd like to express my deepest gratitude to each and every one of you for your valuable contributions. Over the last 2 days, we had delved into critical topics surrounding circular economy and its role in shaping sustainable future. Our discussions have highlighted not only pressing challenges of today, but also innovative solutions. We had approximately 150 plus registrations for the conference, approximately 20% plus papers for the conference itself, and the dignitaries and the speakers we had is a privilege, and we were honored to have them here and humbled to have to listen to those speakers. Our Honorable Vice Chancellor sir was here, MD DMRC sir was here, and representatives from Airport Authority of India, Mr. Seth from Griha, DMRC, we had Mr. Architect Charanjit Singh, we had Architect Gurmeet Singh Chauhan, we had Architect Mathur sir, and the list is such a long. I will just like to invite Dr. Shweta Manchanda ma'am to give a vote of thanks for the conference. Ma'am.
Thank you so much, Rashi. I think she's already wrapped up all the things that we had to say. I really thank ISSDA for bringing this conference here to USAP and GGSIPU. I think we're really poised to, take off. We are very excited to have done this all together. I think it was also, very binding for all our faculty and our students. And I would like to thank the Nickel Institute and the Molybdenum Institute, as well as the Council of Architecture and BMTPC for supporting this initiative, because without that, this wouldn't have been possible. And most of all, I would like to thank all our student volunteers and student participants. I'm sure you enjoyed this conference and you will look forward to more such events. I'm sure you are waiting for your certificates. They're all ready and they will be given to you. I think there were a few short, so which is why we are not doing it formally, but we will give them all to you. All right, thank you so much. I would like to call Dr. Logani ma'am to say the last words. Thank you. Yes, and not to mention the faculty of USAP, the core faculty, the visiting faculty, the contract faculty, everyone has worked very, very hard on this. And I think it is just an unbiased contribution. And I also want to thank the staff, particularly, I don't know that none of them are here. I think Himanshu and Mr. Sarvesh and Mr. Sanjay for working tirelessly day and night. And I want to extend my special thanks to USDI, to Dr. Rananki Nath. She has worked day and night on the website and for mentoring the students on this initiative. Thank you so much.